It looks like we're live. Hello, everybody. Welcome back to yet another live stream. So today we're going to talk about a rather lengthy video of Jeranism. With me, I have Team Skeptic. Hi, how are you?
I'm doing good. We had a great show last night. Nathan Thompson and one of his friends came on who, oh man, Gio, I'm so glad that we're actually talking about this right now because I just realized that I watched one of this other guy's video who claims to be a purveyor of true science. We'll just leave it at that. And he brought up something about microbiology and chemistry in one of his videos. He's basically saying that anthropology, astronomy, astrobiology, astrophysics, anything that has to do with space is fake science because we can't manipulate things in space.
All right. Well, apparently he doesn't understand that we don't actually need to manipulate it. We just have to be able to observe it.
Yes, and I'm going to be bringing you on to actually have that conversation. I think that's going to be a science or satire show that brings you and Micro on at the same time to speak to this guy about his misunderstandings of what real sciences are and how you can't just exclude things like geology because you can't manipulate the Earth.
Neat. When is that going to happen, approximately?
He wants to do it in the next couple of days, so
okay.
I'll try to get
I'll be leaving
up
next Wednesday for a week of vacation, so it would have to happen before then.
Well, I'll make sure that it happens before then. In fact, I think me and Fight the Flat Earth are going to be trying to set up another show either tomorrow or Friday. So maybe I'll try to get in touch with Nathan Thompson and his friend and see if we can't bring both of those guys back on to have them do a 2-on-2 discussion about science. Because Nathan Thompson doesn't believe in science, basically. He thinks it's all bullshit. So.
Okay, speaking about Fight the Flat Earth, he's my second guest today. Hey, how are you?
I'm doing good, thank you very much. I'm still reeling from one of the revelations last night I learned on that stream, and that is that mass and weight are the same thing.
Oh dear, not again.
Yeah, he uses that as justification to say that only in the last 50 years have we been using the phrase angular momentum, and he thinks that the formulas for angular momentum and centrifugal force are the same thing because he thinks weight and mass are the same thing.
So, if I remember correctly, those equations were already derived by Newton himself, weren't they?
Yeah, very much so. Sean pointed out last night that the first time that angular momentum was used that we can notice was 1790. So it's definitely not in the last 50 years.
Yeah. Okay, before we actually start with today's topic, I just want to congratulate the scientists of the Event Horizon Telescope, EHT for short, who today published the first ever direct photograph, the first ever direct picture of a black hole. They used
the accretion disk.
Yeah.
I'm sorry. Was the accretion disk was it perpendicular to us or was it parallel?
Not completely. It's like angle to one side.
Slightly. I think about 20 degrees angle away from us by the looks of it.
Something like that. Yeah. It was rather
really
polar, but it was not completely polar.
Yeah.
Okay.
The fact that they might be able to image that is absolutely incredible.
Yeah. So for the people that don't know, the Event Horizon Telescope, or EHT for short, that's an array of different radio telescopes scattered all over the planet, which they used to actually get this photograph. Now, they didn't actually target the supermassive black hole in the center of our galaxy, which is also known as Sagittarius A star, and which is approximately 250,000 or so light years away. Instead, they targeted a supermassive black hole with a mass of 5 billion solar masses in an elliptical galaxy called Messier 87, which is approximately 55 million light years away.
Yeah.
So
it's managed to verify a whole bunch of stuff that Stephen Hawking was saying about black holes and the way that they would react with things. And it's another visible proof of like general relativity, being a thing.
Yep.
Yeah. So
and just for comparison, the object in question, the Schwarzschild radius, is approximately 36 light hours.
Wow.
So yeah, that's a rather big one.
That's pretty big.
Science, bitch.
Again, 5 billion solar masses. Okay, so congratulations to them. Obviously, the next target, they actually said this during the press conference, the next target for the telescope will be Sagittarius A star. And I'm really looking forward to seeing that one, if they manage to actually get it.
Now we can just send all the flat earthers to a black hole. That would be fantastic.
No, that's actually cruel.
To the black hole.
Yeah. Obviously, on this channel, we do not support black hole cruelty.
No. Flat earth cruelty, however.
This picture of this black hole is actually the second instance of something we could photograph, which is infinitely dense and at the same time hollow. The first time being Anthony Riley.
Yeah, I've been wondering about Anthony Riley with this whole relative density thing. Shouldn't he literally sink through the Earth? Because he is the densest thing I've ever come across.
I don't know. Okay, so Jeranism's video.
Oof.
You guys have both seen it already.
Yeah.
Well, I've only seen part of it. I obviously didn't catch the part at the end when they were talking about space. I only caught the math part at the beginning, and I was like, wow, they're so wrong. They just don't even know how wrong they are.
Okay, let's actually go through this chronologically. So as you guys are right, this video was actually torn up into two pieces. The first one dealt with centrifugal accelerations, for example, and the second one dealt with some Newton quotes. Did you guys notice the one thing that Jeranism didn't do that he should have done?
No, what was that?
Not go on the internet and spout nonsense.
Okay, not a single time did he actually calculate the centripetal / centrifugal accelerations in question.
Oh yeah, no, because that would require him understanding things.
Yeah, I mean, Team Skeptic, I know you actually did this in one of your videos before. Do you remember how high the centrifugal acceleration was on the equator?
0.3% of the pull of gravity, the force of a pull of gravity on a 1 kilogram object.
Yeah, well, when you're talking about the acceleration, the mass is irrelevant because it cancels out.
Right. Mass is irrelevant. I was just saying that the actual equation that I did was on a 1 kilogram object, and I measured I calculated a 0.3%, 1/3 of 1% difference.
Yes, it's the same for the acceleration. So if you actually plug the mass of the planet and the radius of the planet into the equation for the gravitational acceleration, you end up with a 9.8 meters per square second. And for the acceleration due to the centrifugal force, you end up with approximately 0.3 meters per square second. So so no, sorry, that's not correct. 0.03 meters per square second. So yeah, as you said, approximately 0.3%.
Yeah, 0.3%. You're right.
This is something that he actually didn't do, and which rather surprised me because he actually had both equations in the video at one point.
Which just goes further to prove the fact that he has no idea about what he's actually talking about. Someone's probably mentioned something about how they think this equation should be, and then he's just run with that. I mean, he's got those equations on screen, but he has no idea what those equations actually represent.
And we're talking right now about Anthony Riley, correct? Not Jeranism. Oh, but we're talking about this video now? Okay.
Yes. Okay. So I suggest we just go through the video piece by piece. And I know that it's almost 40 minutes long. So it's possible that we might not be able to do the entire thing today.
Why can't flat earthers just do, I aim to get under 20 minutes. I don't like doing videos that are over 20 minutes. But flat earthers seem to not do any videos that are less than half an hour.
Well, I think a lot of it has to do with they will. If you get a long video, right, globe earthers are not going to sit through and watch. Unless it's me, you, or Geo, who's trying to find the flaws in what he's saying. A globe earther is not going to sit through and watch for 40 minutes. They'll just say, nah, and move past it. It's the flat earthers that are actually going to sit down and watch this video. So he'll through that process, he'll get a good audience retention. He'll have, it's just, he'll get more money from revenue. More commercials will post through it. There's a reason for doing longer videos like this. especially when you're in a niche community like he is. For us, it makes sense to do a 10-minute video because we're just making fun of them, and then we're moving or pointing out their all the points that they're wrong. So their 40-minute video might take us 5 minutes to make a video to say, oh, he's wrong here, 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 and here.
Yeah. I wish I had that ability to just waffle about nothing.
Well, believe in some nonsense that nobody can fucking prove right or wrong, and you can feel 40 minutes of saying whatever you want.
Oh, all right, let's do this. Fresh hell.
Let me know when you guys are ready, and I'll start the video.
Just go ahead.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Yes. Yes.
What's going on, everyone? It's Jaron from Jeranism, back with another video for you today. Are we spinning? Should be a short video, as the answer is clearly no, we are not. All right, hope you guys enjoyed the video. This has been Jeranism. Till next time. No, okay.
Oh, man,
Maybe we need
a
a bit more detail here. But let's make sure that we all agree that no one has ever felt these ridiculous speeds.
Stop.
It is assumed.
Okay. Do you have any sensory system, right? Do you have any organ with which you can feel speed?
No.
Constant acceleration? No.
Yeah, no. Well,
I mean,
well,
constant velocity. Constant velocity? No.
There we go. That's the exact problem about this. You actually are not able to feel speed.
And that's why we have to develop tools for certain things. The flat earthers and Jeranism especially are very keen on saying, trust our senses, trust our senses. But our senses can't see in ultraviolet and infrared and detect motion and detect the Coriolis force. You know, we need tools for these things.
Yeah. Well, he will make the claim later that obviously we should be able to feel the forces involved. But we just don't.
Well, you don't, because it's an overwhelming force of acceleration towards the center of the Earth. So you don't, even if you had something set up to measure this, which they do, they have accelerometers that can measure the X, Y, Z axis of acceleration, which then separates, the acceleration down of gravity from the acceleration around on like the circular acceleration. So, but you yourself, no, you'll never feel the centrifugal force whatsoever. You'll only feel less of a gravitational force,
Which isn't very much anyway.
right?
Well,
You only feel one force. You only ever feel
Already
one
calculated
force.
this.
Yeah, you only really feel one force acting on you at any point. Like, you can have a million forces pulling you in different directions, but all you're going to feel is the one force that is the combination of all those forces added together.
Yeah, you'll feel the net force.
The net force, exactly.
Presupposed and taught to children as fact. Even though, has anyone ever felt the 1,000 miles per hour that we are said to be traveling at the equator? No. Has anyone ever felt 66,000 miles per hour where you're flying around the sun? No. How about
hold
the
on.
480,000
Stop
miles
it.
per hour?
I am. I had to move just
Okay.
1 second.
Do you feel the 1,000 miles per hour or so that you travel in an aircraft?
No.
No, not at all.
Well, I'm aware that commercial aircraft fly at approximately 1,000 kilometers per hour. But as we know, the Concorde was a thing. So, yeah, we had commercial aviation going at higher speeds.
But then their argument for that is that, well, does the aircraft have a top on? Which really doesn't make any sense to me, because like they're trying to say, oh, well, why are we feeling these things? Because there's no top on the Earth, but there's nothing outside of the Earth to feel it against.
Yeah, exactly. There's no friction that the atmosphere is feeling against the vacuum of space, because there's nothing literally to have friction with.
They're just never going to get it, are they?
No.
No. No, never. No. Just like last night, the guy did. He couldn't understand what he literally said. Fictitious forces don't exist. That the centrifugal force is an actual force that's pulling you outward. And I said, what happens if you clip the line? Does the because he was using the coin spinning around your head, and I was like, what happens if you clip the line? Does the coin go straight out, or does it continue on its path of it with its tangential velocity? And so what continues with its tangential velocity? Well, then the centrifugal force is a fictitious force. There's nothing actually pulling the coin outwards, even though the coin is feeling it being pulled outwards. Even though you can measure this force, the force doesn't exist, because the moment you take away the centripetal force, the centrifugal force goes away instantaneously. And
their problem is that they have these words that that they think mean things, and then they just stick with it, and they don't really understand what they're actually saying.
Are you ready to move on?
Yeah, sure, go ahead. No, wait, before you go ahead, stop. Obviously, the same argument applies for the other speeds that were mentioned, which are the speed of the planet around the sun and the speed of the solar system around the center of the galaxy.
Yeah. All those angular momentums are so small that you're not going to feel them. If we were traveling at those speeds...
Stop right there. You're already mixing up angular momentum with gravitational attraction, in this case, the centripetal force.
Okay, yeah. No, I was talking about like the solar system going around the center of the galaxy.
Yeah, but the angular momentum is irrelevant. What's relevant here is actually the gravitational acceleration.
Okay. Sometimes I get those confused.
Yeah, you have to be very careful.
Well, the thing is people have said that I was wrong in saying that the Earth was when I said that if you were to take all of the forces combined, all of the centrifugal forces combined, let's say you were on the Earth spinning and you were, you were in a position to where the sun was on the other side of the Earth. So you're actually spinning, and at the furthest away, you're at the maximum amount of acceleration. Plus you're at the point where this is also aligned with the center of the galaxy, so that you're getting all the forces pulling on you inward at that point. I was like, when you take all of that and you combine all the centrifugal forces up that are involved, and they were like, no, it's not centrifugal force there, it's angular momentum, because you're not actually working with friction there. So and I just don't want to be wrong. So maybe I said it wrong. You guys feel free to correct me.
All right, let's go on with the stupid.
Galaxy. No. What about the 1.3 million miles per hour that we travel with the Milky Way galaxy around the Great Attractor? No. In fact, they could change it to 91.5 billion miles per hour, and would anyone feel a thing? No. And as crazy as those numbers even sound, we are told that the closest star to us is some 25 trillion miles away.
Right. What's his issue with big numbers? Is it just big numbers mean fake?
Big numbers are scary for him. That's the problem. That's the thing about the human mind. We actually cannot grasp those numbers. We cannot just imagine how large those distances in this case are. And this is what scares him.
I mean, and they still don't understand that speed is relative. So if you have two objects, one of them traveling 1,100,000 miles per hour in one direction, and another object traveling 1,000,000 miles per hour in that same direction, well, together the relative speed from each other is only going to be 100 miles per hour. I mean, they're only going to separate by that amount. They're not going to separate. You're not going to be able to go, oh, we're traveling so fast, and how do we maintain this distance? Well, if you were to do that on like let's say a Frisbee, and you put two dots on a Frisbee, and then you think about it like that, you say, oh, it makes a lot of sense. I could take that Frisbee and throw that Frisbee as far as I want, make it spin as fast as it want. And guess what? Those two dots relative to each other will never change distance. They will always remain the same distance to each other, no matter how fast that Frisbee is spinning and no matter how far you threw it. And it's the same thing going on inside of our galaxy. We're all just basically in a big Frisbee. And as we travel through the galaxy or universe, we travel together.
Mm-hmm.
Okay, by the way, his claim that the next star, which is obviously Proxima Centauri, is 25 billion?
Trillion.
trillion miles away. And obviously that's easily disprovable using parallax.
Yeah.
And I'm pretty sure you guys are aware of how that works.
Yeah.
Yeah.
Okay, great.
Just numbers and just math needed to show that we are in an ever-expanding, limitless universe flying around at ridiculous speeds, but none of us has ever felt a thing. Now, before we get too deep, let me say, as I always do not trust me.
Okay.
Do your own research. This video is my opinion. I want to show some reasons why I think there's no way that we are spinning.
Right, pause it there. Right, I have a real issue with this. People keep saying to me, "Oh, why does my opinion on the shape of the Earth matter to you? Why does my opinion about maths and physics matter to you?" Because it's not an opinion. You know, you're perfectly entitled to your own opinion, but what you're not entitled to is your own facts. So stop saying this is an opinion and trying to push it as a fact.
Yeah, as soon as he claimed that, for example, that Proxima Centauri isn't the distance away that we know that it is, he's making a claim there.
Yeah, it's not an opinion at all. You can't have an opinion about a distance.
Yeah, you're absolutely right. That's what these guys are misunderstanding. This is not about opinionated. Like, I have an opinion on your misunderstanding of the fact. You're putting out a video where you're making factual positive claims that are factually incorrect. And we are here to explain to you, and whoever may unfortunately see your video, that you're wrong. Point blank. There's no ifs, ands, buts about it. You're wrong, Jeranism.
Yeah.
To their own beliefs, and they need to make up their own minds. You are free to believe what you're taught. You're free to believe that you are spinning on a space rock in the vacuum of space around a sun that is just one of over 100 sextillion stars. You can believe that if you want. Or you're free to open your mind and to question what you're taught. The only problem is, if you question it, you face the criticism and the name calling. To fit in with society, you better accept what you were taught, or else you'll be labeled and shamed.
I want to speak on that. That's absolutely not true. In history, we have put forth the people that are the great experimenters of our times, the great discoveries. Every one of them are put forward, and they're revered in the scientific community. We don't shame the people who come with different ideas. Niels Bohr had a completely different idea than Albert Einstein about quantum mechanics. Okay. And he didn't get shamed, even though his theories were completely against the most popular scientist of his time. He won that battle, in fact. And guess why? Because
that's the point about science. That's the point about science. When new ideas come in and when we are actually proven wrong, we acknowledge that, and we would thank the person that discovers that we are wrong for correcting us.
Yeah. And the thing is, they try to correct us, but with things that are clearly not right. So they want us to be thankful and in awe that they've discovered these things, but all they're discovering is that they don't understand maths and physics.
And also, when we arrive at the point where we are today, we pretty much have determined the properties of the universe to such a degree that we can confidently say that this is approximately true. And somebody comes around with something that is so out of reality, literally, which is so ridiculous, which is so way out of what has already been measured and been verified.
Mm-hmm.
Then we have the right to actually laugh about them.
Very much so.
I mean, I literally saw a video. I'm trying to remember. I think it was Thrive and Survive. Mr. Thrive and Survive posted a video about a physics professor who was trying to say that Newton's laws were incorrect. And he was literally showing somebody throwing a ball and the person moving backwards, and then trying to say that that was incorrect, that's not, Newton didn't have it right.
Oh,
and
yeah.
I'm like, are you kidding me? Like, you're a physics professor. You will get laughed at. If you can prove that Newton's laws are incorrect, then you're going to be a what's that prize they win? I can't. It's a
Nobel Prize, maybe.
No, but yeah, if you can replace Newton's laws of motion with your own laws of motion, you're going to get a Nobel Prize. But if you can't, and if you continue to push the fact that Newton's wrong, but you can't prove that he's wrong, you're a quack. and we're going to laugh at you.
Well,
Anything else before I start it?
No, please continue.
There's so
recent
much.
video called "The Rise of Flat Earth Creationism." Let's listen.
The label and shame tactic. It's something we've seen frequently in the media. It's what spawned belief in the Jussie Smollett hoax. If you're a flat earther, you won't be called a racist or white supremacist. You'll simply be thought of as a silly moron. The use of the shaming tactic, though, is quite clearly
idiot.
to prevent discussion,
Ding.
covering up an inability to intellectually debate or trying to affect your opponent monetarily. A fast track to victory of sorts. Is this true for those who mock flat earthers? What the flat earth model leads to, and what many say the ridicule is meant to hide.
Did he just say what the flat Earth model?
So he's claiming that there's a flat Earth model all of a sudden. I mean,
Yeah.
he's showing an AE map over here, so he kind of claims that that's correct.
But we know the AE map in no way, shape, or form represents reality.
Yep.
Cannot.
And even some
control
fluffs
reality.
have acknowledged that.
Oh, many Earths have acknowledged that. And that's when they just quite casually throw out the term like the flat Earth model. I would love to see this model because the definition of a model is something that can accurately make predictions. So
Yeah.
please
How do you know you're right or wrong if you don't have a model to compare observational
Yeah.
reality?
just saying flat Earth model doesn't mean you've got a model. A model means you have to have a mathematical model that works together with all the formulas within it, all working together to be able to make accurate predictions about the universe we're in. And there is no such thing that comports to a flat Earth.
There's also another thing about this. When we actually label people as idiots, we don't just do this. The next step after calling somebody an idiot is exactly pointing out where their thinking is flawed.
Yeah.
Right.
That's-
Right.
Whereas the flat Earthers,
whenever we say you're making a stupid argument or you are stupid, we immediately point out why.
Mm-hmm.
I would say that in this community, I am Captain Ad Hom, right? Because everybody thinks that what I'm doing is ad hom attacks. It's not. It's not an ad hom attack. An ad hom attack is when somebody goes, the earth is flat, and I go, no, it's not because you're an idiot. That's an ad hom attack. If I go, no, you're an idiot, the earth is not flat because every flat earth model out there does not comport to reality. This is why you're an idiot. You're an idiot for believing something that's obviously so wrong.
Mm-hmm.
That's why you're an idiot. You're not an idiot because the earth's not flat. That's not it. It's the earth's not flat and you're an idiot for believing it is.
Yeah. Whereas they will just go, nuh-uh, you're an idiot, and then have nothing to back it up.
You're indoctrinated. That's my favorite one. Oh,
Yeah.
you're so indoctrinated. What the fuck ever.
Move on.
Is that a firmament or a dome would completely ruin hundreds of years worth of indoctrination and propaganda. NASA and the space program, space in its entirety, would all be a big charade. Movies, science, school curriculums, all methods of indoctrination to keep this spinning
What did
line
I
alive.
say?
From the air age through the missile age and into the age of space. Our space age heritage of knowledge is older than a decade, older than a century, older than a millennium. Our scientific knowledge has evolved through the ages concurrently with the minds of men. Our capacity to learn has expanded in the process.
And so, opening one's mind comes with the labels, and then the shame, and it's all by design.
Stop.
Well, if you accept the religion,
Yeah, it depends on what you open your mind to.
Mm-hmm.
If there's some credence to what you think, then nobody's going to shame you for anything. But if your ideas become progressively stupid, as do yours, then yeah, we will call you out on that.
Exactly. Like when they don't have a point to actually get to, it's so easy to call them out on it.
space, well, this gets you opportunities and an easy way to fit in and to seem smart. It's gravity, you fool. You ever heard of Newton's laws of motion? So even questioning whether you are spinning right now or whether you are flying about the universe at 1.3 million miles per hour comes with some back.
So he has mentioned gravity and Newton's laws of motion. We will not just only throw those words around. We will explain to you step by step how we got to know that those are correct and how they need to be applied and why.
Right.
Oh, looks like we've got Gary Webber-Wanger in the chat.
Yeah.
Yeah.
I haven't
Okay,
shaved my ball
even if
sack
he's
for a
flat
while.
earther,
He can swing.
Even if he's a flat earther, he's wrong. Just check out how the geographical position of Japan was changed during the last big earthquake in 2011.
I'm questioning it, so get over it. Now, we're about to talk a little bit about math, and so I hope people understand that despite what you might hear elsewhere, math is not reality.
Pause.
Math is a human creation.
Well, yeah, okay. Math is not reality, but math is the only thing that is a universal language capable of describing reality.
Yes, that's pretty much what it is. It is a language which has this quantifiable nature to it.
Yeah. And that's why we use maths, because we are able to quantify things. We are able to break down time into units so that we can quantify it and measure it. That's the whole point of maths. It's so that we're able to describe the universe.
Yeah, obviously, what needs to be pointed out here is that units are pretty much arbitrary.
Yeah.
This is why natural constants are a thing, because they're pretty much what we use to actually adapt the actual values into our unit system. Right? They are a correction factor, nothing more.
And what's going to happen now is Jeranism is going to try and use maths to prove that maths isn't real.
Yep, pretty much.
He's going to get a lot of math wrong right here, or a lot of explanation of math wrong right here. So we're going to correct him. I hope he watches this and learns something.
He said he wouldn't watch it. I had, for those who don't know, whenever I'm talking about something that the fluffer produces, I'm actually inviting that fluffer to the hangout. Because I think, in my opinion, they have the right to defend their stuff. I had a chat with Ernest earlier via Skype, well, text chat via Skype, and he said that he wouldn't watch it and he would join. But who knows?
Yeah. When you don't want to know the truth, that's a great tactic to have. When you would prefer just to stay ignorant of it and hold the position of ignorance, so nobody can say you're an idiot. You can always say, "Well, I just didn't know." Yeah, well, we're inviting you, Jeranism, so that you can know, so that you don't make these mistakes in the future, so we don't have to call you an idiot so many times, even though I do appreciate it. Here you go, Jeranism. This one's for you.
Well, before we continue, there will be a rocket launch this night. So for the people in the United States who will actually be awake from when this happens, 8 p.m. EDT is the scheduled time. Falcon Heavy, the second launch of this rocket type. So have fun with that.
All right. Are you ready to keep going?
You may continue.
Reality, it cannot prove it. Why? Well, because we invented it. If the foundations are wrong or the axioms are off, then it can appear to be reality, but it is nowhere close. Math is math, not science. Math is the culprit here. Things that are said to be true because we say so. Because Einstein wrote some equations that say that space-time can be bent doesn't make it true that space-time even exists, let alone that it can be bent. It's math.
Well, pause. I'm pretty sure that the recent discovery of a black hole helps verify Einstein's predictions of space-time, right?
I need to correct you there. We knew that the black hole was a thing. We just weren't able to take a picture of it yet.
Yeah. So, but taking a picture obviously helps verify everything, surely.
I mean, obviously, there was the possibility that this would be a naked singularity, which is actually a hypothesis.
Mm-hmm.
But yeah, it was very unlikely that this would be the case. Obviously, that there should be a black hole around the singularity. And yeah, we confirmed that.
Carry on.
That ignores experiment, but instead builds its knowledge around agreed upon equations. In a Vsauce video titled How to Count Past Infinity, Vsauce states, and I quote, "This is math, not science. The things we assume to be true in math are called axioms, and an axiom we come up with isn't more likely to be true if it better explains or predicts what we observe. Instead, it's true because we say it is."
Stop.
I was stopping it before you even said it. Go ahead.
This is similar to how languages work. A word doesn't have a particular meaning to itself. We describe a meaning to it. And this is how math works. This is how the entire relationships in maths work. This is how we define multiplication. This is how we define dividing, and so on and so forth. Yeah, those are pretty much axioms. Those are definitions that we use. But we can still use them because they have practical application, just as every other language has. Right?
Yes.
We can use it to communicate with one another and to share information with one another.
Yes. So, like a good way of explaining what he was saying, and I was trying to bring this up yesterday in Red's hangout, but they were wanting to talk about the second half of the video more, so I held it for this part for me and you. In math, an axiom is like 0. Okay. So if you ask somebody to explain to you what 0 is without using math, they can't do it. It's impossible to explain nothing. It's best to just be silent because that's what 0 represents. It doesn't represent a value. It represents an absence of the concept of value. So when you're in math, math is the way to prove things. We can prove 0. We can prove it exists. We can prove it has practical applications using math, but we can't do it by just naturally explaining it. So therefore, it becomes an axiom to us. It's something that we accept. We accept 0 to represent the concept of the absence of something there. This is why you can't divide by 0, because you can't divide by a concept that doesn't exist. It's like leaving a blank space under the divide sign. We put a 0 there because we don't want to leave the blank space. We don't want to say that there's an absence of numbers, an absence of quantity. But we have to express that in a mathematical language, and we do that with the term 0. So that's why we have to. We don't have the ability to show you 0. So we have to just accept the fact that 0 represents this in reality. And once we do that, then we can apply it to math.
Yeah. There was some cultures that didn't use 0, wasn't there?
Yep. The Romans didn't have the number 0.
And that caused problems.
I don't actually know how the Romans used mathematics.
Yeah. Well, they knew what straight was anyway. They probably knew.
Hey, CK says I'm not technically right. What did I get wrong about that? About dividing by 0? Because I'm pretty sure that I'm right. I could be wrong, but I'm pretty sure I'm right about that. This is what I went to when I was in college. I majored in math. So.
All right, should we get on with it?
CK just answered. Division is how many times do we mention the denominator to get the numerator, and having 0 at the bottom will mean basically nothing. Nothing. Yeah, that's true.
Isn't that what I said though? It's like having nothing underneath.
I think so.
True, because we say it is. Well, good thing we can never fall victim to being fooled through math. Oh wait, it's actually a perfect way to be fooled. He goes on to say, and I quote, "Its consequences just become what we observe. We are not fitting our theories to some physical universe whose behavior and underlying laws would be the same whether we were here or not. We are creating this universe ourselves."
Yeah.
End quote.
Stop. Yeah. What he's saying here is that we actually have to translate how the universe behaves into a language that we can understand. And this is why we're using maths, because we can understand maths.
Yeah.
At least every single one can to a certain degree.
If everyone understands maths the same, then everyone can quantify things in the same way and exchange information in the same way. But Jeranism's version of maths would cause a lot of problems.
Okay, I see what Saif is saying. Yes, Saif, well, I'll have that conversation with you offline somewhere, because I see what you're saying. Basically, I'm saying the same thing, but I see he's talking about why it's in our numerical system, and he's right also about it being in the denominator, which, you know, basically when you take 0, when you take something being divided and you just switch it over to the like the multiplication. So you're removing the division symbol. You're basically saying how many times do you multiply something to get into another number, and it doesn't make sense when it's 0. So, but it is in the numerical system for reasons. But we'll talk about that because that's a whole different topic, and I'd like to keep this on topic with what we're doing. But yeah, we do what Vsauce is saying. We are creating this universe mathematically. We're explaining it. We're explaining our observations in a way that we can understand it and make predictions.
Please continue.
Yes. This math, you can create whatever you want. A physicist has said before that one can create an equation that says an elephant can hang from a cliff holding on to a branch only. And while math may say this is possible, reality knows better.
Stop.
He then states quite plainly, and I quote again,
Stop. Okay, so 2 things here. First of all, notice how he actually cited, or he will cite the sources later on, but in this particular case, he didn't. He just said a physicist said that.
Oh, yeah. Anecdotal.
Okay, yeah, that, and I find that rather suspicious. Second of all, yeah, you could derive an equation, but the problem is you would very quickly find out that this equation doesn't work. So yeah, mathematics alone could do that, but this is what physics is, right? You have to check the hypotheses that you develop in the real world. And in this case, you would find out that no, it doesn't work.
That's why when you're studying physics, you don't just sit down and learn the equations. You go and you find practical applications to test the equations, to see that you understand what you're actually doing and how it applies to the natural world.
Yeah, not only in physics, but in all kind of, well, in pretty much every field of science where mathematics is involved, in chemistry and biology.
Yeah.
Civil engineering, I mean, good luck with a car that isn't designed according to the laws of physics. When
yeah,
you get
right.
your car crash. Have fun with that one.
so to what extent we're inventing all this or discovering it is hard to say. End quote. Very hard to say. But one thing we can certainly not say is math is reality. Let's remember that as we cover some of this math.
Yeah, math is not reality. Math explains reality.
So, are we spinning? First, whenever we're discussing this topic, many people will want to use angular speed. Why? Well, because the angular speed is the same no matter where you might be on Earth, while linear speed is simply distance over time. So we can make this simple with this simple circle animation. Consider first this circle is a merry-go-round with a circumference of 100 feet. Now, clearly, to anyone who can just think at all, the blue dot, and we can pretend these are horses since this is a merry-go-round, the blue horse moves faster over a given time. The green horse moves the slowest because of the equation distance over time. The blue horse is going around 100 feet in, say, 4 seconds, but the green horse, which has a much smaller circumference, is going only 10 feet in that same 4 seconds. But if we use angular speed, well, then both the green horse and the blue horse have the same angular speed, but very different linear speeds. The blue horse is going 25 feet per second, and the green horse is going 2.5 feet per second, 10 times less. This makes sense. Someone at the center of the merry-go-round will definitely feel a different speed than someone at the edge.
Pause it.
However, if we use angular speed, as most globe proponents will...
So he's just used maths to describe what he's talking about there.
Yeah, obviously there's hypocrisy going on there, or at least double standard. Before he said that you shouldn't at least use maths to describe reality, but now he's doing exactly that.
Yeah, that's my point. Like it's when it suits him. That's when maths is reality.
Yeah, and there are different applications for using linear speed or using angular speed. I mean, they're not one and the same. They just, like, linear speed can be for something that's in a straight line that has no angular speed. You know, if you don't, and angular speed can, I don't know, it's hard to explain that to say that there's two different applications for each one. There's no, you can't combine the two just because you want to combine the two, just because they're representing the same event going on. They have practical applications that are completely different from one another.
And what he also doesn't understand is you can actually, if you know how the entire system looks like, right? If you know the diameter and the frequency at which this merry-go-round rotates, you can actually convert one into the other.
Right.
Then the speed of the horses is all the same. They're all moving the same angular speed. The blue horse on the outer edge and the green horse towards the middle. So it makes sense why they want to use radians and talk about angular velocity, because they would be the same. But we know someone at the outer edge of the merry-go-round would always move faster than someone near the middle. Here we have an article from fizzlink.com that asks, if I'm on a merry-go-round with a friend and the friend is closer to the center than I am, are they going faster than I am? And the answer is no. You're going faster. The merry-go-round is rotating with uniform circular motion. That means that it rotates at a constant angular speed. They then go through a little bit of the math, which again shows that if you mean linear speed, then someone at the outer edge moves fastest. But since you're both circling with uniform circular motion, you are both moving the same angular speed. But again, the closer you are to the middle, the slower your linear speed is. The next little trick that globe believers use is to say, well, yes, we are spinning 1,000 miles per hour at the equator, but we're only going around once per day. No one could ever feel that. Well, in a sense, they're most certainly correct. On our merry-go-round here, if the blue dot moved around at...
What's that?
Did he just acknowledge that we couldn't actually feel that?
Yeah, he said in a sense they're correct.
Well, in most senses they're correct.
Yeah. And that's the thing. You know, you stand still and turn around, but take 24 hours to do it. That's the kind of speeds we're talking about.
Yeah. It's nothing. It's nothing at all. It wouldn't cause water to fly off a tennis ball if a tennis ball was spinning at 15 degrees per hour.
One rotation per day, you wouldn't even know it was moving. It would be so slow. But here's the trick. Remember, this merry-go-round is only 100 feet in circumference. So let's extend that to, say, a mile. So now the merry-go-round goes around 1 mile per day. Now, would the blue horse know that it was moving? Well, just barely. Not quite like grass growing, but if you looked out, you would be able to tell that you were moving. But it would be very, very slow. You'd be moving at about 1/25th of a mile per hour. But to see if we'd notice flying 1,000 miles per hour at the equator.
Did he just say you'd be moving at 1/25th of a mile per hour?
Yeah.
You're not going to feel that movement right there.
No.
You'd barely be able to detect it visually looking outside. Trees waving in the distance would be moving faster than you are moving relative to the tree.
Yeah,
but even then, you are determining your speed by actually looking at nearby objects.
Yeah, that's the point of speed. It's relative, right? So
yeah, which is obviously not possible on the Earth. Right? Parallax angles we're talking about are much smaller.
I mean, it almost sounds like he's getting it at this point. It almost sounds like he's explaining it right, but then he's just going to go off on a tangent and forget that some things he got right.
All right, let's keep going.
We'd have to take that small speed we were just talking about, that 1 mile per day, and multiply it by 25,000. Think of anything moving at any noticeable speed, and then think times 25,000. It's ridiculous. Think of seeing a car drive by at 30 miles per hour. Okay, well, 25,000 times that is 750,000 miles per hour. Ridiculous. So think of a car going 1 mile per hour. Now times 25,000, that's 25,000 miles per hour. So I hope.
Why is he coming up with this math?
First of all, why is this ridiculous when there's no friction with the vacuum of space in this case? Right? Obviously, you cannot accelerate a car inside the atmosphere to 25,000 miles per hour because it would pretty much burn up instantly.
Be cool to watch.
Obviously, it would be cool to watch, yeah. But it's simply not possible.
No. And that's one of the reasons why we know the ISS isn't in our atmosphere, because, you know, Redra, Erica, and Astronomy Now have confirmed how fast it's going, and any craft in our atmosphere going that fast would burn up.
Also, don't forget the fact that when it comes to aerodynamics,
yeah,
let's just say the ISS isn't very aerodynamically shaped.
Yeah, that thing would fly like a rock.
Advantage whatsoever.
Oh, carry on.
See how insane it is to multiply any speed by 25,000. But that's what we need to do to compare it to the speed that we're moving on the Earth. That merry-go-round at 1 rotation per day, which is 1 mile per day, needs to be multiplied by 25,000. the speed would send anyone flying off the Earth without a doubt. Let's get back.
0.03%.
Yeah, there we go. He
No.
doesn't understand how small the actual centrifugal force is.
Right.
Or the centrifugal acceleration, because obviously we don't give a fuck about the weights, or the masses, sorry. The masses.
Right.
Because using the acceleration alone, we can actually eliminate that factor. Because we know that all objects will feel the same acceleration.
Yeah, and Gio's exactly right. It means nothing to say, oh, things would go flying off. That's being so intimidated by a 5-digit number that you completely disacknowledge or don't acknowledge fucking the force holding you in place.
That's the thing. Yeah, they won't acknowledge that there's other things going on. It's just this one big number that they can hold on to and say it's ridiculous.
Yeah, and Scythe points it out real good. If you take that 1,000 miles per hour and you drop it down to a mile radius, you're gonna fly off.
Yeah,
you're gonna fly off and go all over the place. That's fucking a high angular momentum at that point. So you won't be held by that. You won't be experiencing the same force there. You will be experiencing a much larger centrifugal force pulling you outwards.
For example, and how it compares to Earth. But my hope is that you realize why I think angular velocity is just not needed here and why globe believers will jump to use it. They want to use angular speed because they want to say that both the blue dot or the gray dot, the red dot, and even the green dot are all going the same speed.
Stop.
Angular.
Go ahead.
I'm actually sharing my screen for a second there. Can you see my screen?
Yes.
Okay. Do you see the big as long equation in the beginning that says centripetal force?
I do.
Okay. Can you see that after Fc equals m times a, there are actually two equations there? Well, one equation, but two parts of the equation.
Mm-hmm.
One being m times v squared divided by r, and the other one being m times r times omega squared, and omega being 2 pi divided by t.
Yes.
Okay. Do you see that 2 pi divided by t is the angular speed and v is the tangential speed?
Yes.
Do you see that you could therefore plug in either of those two numbers into the equation and actually get the same centripetal force?
Yes.
There we go.
Jeranism.
Jeranism, it doesn't matter which one of the two units, sorry, not units, how do they actually call those physics in English?
Equations.
Well, yeah. Yeah, but what is v and what is t? I just don't know the English word for this.
T is period, time, and v is velocity.
Well, yeah, I know that, but like more generally, wait a second. I have to look up that word.
Oh.
I'm sorry that my English isn't perfect.
I think I'm just
Physical quantity, thank you.
Quantity, sorry.
Thanks, Wikipedia. You can use either of the two quantities, plug that into those formula, and get the same fucking result.
But maths isn't reality unless Jeranism wants it to be.
Oh, yeah, sorry, I forgot. Okay, going back to you, Team Skeptic.
Some do that. Linear speed does not. So linear speed says that the horse on the outside has the greatest linear speed because obviously it has a greater radius. And angular speed says the speed of all the horses is the same because they all make one revolution in the same time. Okay, moving on to a globe Earth. Since we know linear speed is simply distance over time, we can easily figure out the linear speed for any location on a globe Earth. The circumference of their latitude, which would be d, over time of rotation, 24 hours, which would be t. So at the equator, we have a circumference of 24,901 miles. We divide that by 24, and we get its linear speed of 1,037 miles per hour. For Los Angeles, we get a circumference at that latitude of 20,670 miles. Divide that by 24, and we get a linear speed of 861 miles per hour. For Anchorage, Alaska, a circumference at that latitude is 12,000 miles. Divide by 24, and we get 500 miles per hour. Move to the tip of Greenland, circumference of 2,771 miles. Divide that by 24, we get 115 miles per hour. and just outside the North Pole, a circumference of 86 miles, divide that by 24, and we get about 3.5 miles per hour. And again, with linear speed, this is very easy, right? The equator, 24,901 divided by 24 is 1037. Alaska, 12,000 miles circumference, 24 hours equals 500 miles per hour.
All this math he's using.
You know, I was going to say something. This is a great video to have, like when you want to explain the Coriolis of force. You say, okay, now if you see here where Jeranism calculated the different linear velocities.
Well, first of all, you have to be
This is
careful.
going to be your conservation of momentum here.
You have to be careful. The forces you actually get out of this is not the Coriolis force directly. It's only the
no. I'm saying
of this force that you get there. Only the horizontal component is the Coriolis force. The other one is actually the driving force of the Eötvös effect.
Right. I'm just saying, like, you could use this as part of that explanation to say, look, here's proof right here. Here's a flat earther that's calculated the different linear speeds here. Are you ready to move on?
Using math that isn't reality.
Yeah. You ready to move on?
Yep.
Please go ahead.
Now let's look at angular speed. So the equation for angular speed is velocity equals the angular speed times the radius. So 1037 miles per hour equals the angular speed times the radius, 3959. So the angular speed equals 0.26 radians per hour. So now let's look at the angular speed of Alaska. Again, V equals WR. So that's 500 miles per hour equals W times the radius of 1910. So W equals 0.26 radians per hour. So now you can see that the math is what allows it. The equation for angular speed, no matter where you...
No, the math does not allow it. The math describes it. The angular momentum is literally, the angular speed is literally something that describes how things travel in a circular path at different radiuses and go from start to finish in the same period. That's all it's talking about. Like we use math to describe that phenomenon.
On Earth is always 0.26 radians per hour. And if you see here, if you go to this site, this little conversion tool, and put in 0.26 radians per hour, what does that equal? Well, it equals 0.999 rotations or revolutions per day. So now you can see how they always want to discuss this topic with angular speed, because linear speed exposes the nonsense.
Stop.
Because angular speed says that all horses anywhere on a merry-go-round are...
All right, go ahead.
Linear speed exposes the nonsense. Yeah, wait a second. So, just wait. Can you see this equation? This one.
Yes.
Okay. Can you see that you can calculate the centripetal force by either using the linear speed or using the rotational speed?
Yes.
Okay.
Yes.
Do you understand that you can actually use both to arrive at the same result?
Yes, but I'm betting Jeranism doesn't.
Well, we'll see. Going back to your team.
moving the same speed. And get this, that's no matter how big the merry-go-round is. That's crazy talk. Think if a merry-go-round was 1 million miles in circumference. To think that all the horses on the merry-go-round would move at equal speed is kind of loony.
That's just fucking your inability to conceptualize your thought experiment. To me, it sounds perfectly fine. You say, oh, we make the circle 1 million miles wide or in radius, and now we have to imagine them going faster so they can maintain their angular momentum. Well, okay. Or their angular speed. Oh, okay. So you're basically saying that you're making an observation that they are maintaining the angular speed, and you're saying that with this 1 million mile radius, how fast are they going? And you use math to determine their linear speed. It's not, math doesn't make it possible. It's possible because it's possible. Math explains what we are seeing here, what's actually going on in this phenomenon.
Yeah, that they think that maths has been reverse engineered, but this is exactly the opposite. We take our observations, and then, from the observations, that's where we get the equations and everything.
Well, we can say that pretty much the laws of physics are reverse engineered, right? Because we take the properties of the universe and actually try to make them
Make sense of
comprehensible
them.
and something that we understand.
Yeah. Right. So that we can make predictions about it in the future without having to be so lost. I mean, that's what math is. It keeps us from being lost and not understanding reality around us.
Being on an inner,
Were you going to say something, Fight the Flat Earth?
No, carry on.
then be taken to an outer horse near the edge. Wow. And so they want us to think that no matter where you are on a merry-go-round, it would always feel the same. That's
Stop.
truly insanity.
Did you notice that he just accidentally described what the Coriolis force is?
Yeah, he's good at accidentally doing things.
I actually didn't notice this the first time I watched it, but he's saying that you would feel actually the forces that apply to you when you move from a horse in the center of the merry-go-round to one that's further outside, which is exactly what happens with a Coriolis force on the surface of the planet, right? Which is exactly why, for example, tropical storms rotate in a certain way, and which is why rotating storms, well, large-scale rotating storms are not possible near the equator.
Right.
They don't pass over the equator.
Yeah.
Well, I think when I did my research on that, there are hurricanes that have passed over the equator, but they pass over the equator with the like as they're breaking up. They can't maintain their rotation once they get beyond the equator. It's the Coriolis forces begin to tear it apart immediately. In fact,
Yes,
it begins
exactly.
losing rotation as it.
As soon as you hit the equator itself, obviously there will be no Coriolis force, and therefore the shape of the storm will start to degrade. And as soon as you pass over it, then the Coriolis force will actually counteract the rotation of the storm, and therefore tear it apart pretty much instantly.
Yeah, but they have been recorded to make it across the equator before, but like I said, it's almost as if at that point it's lost its actual storm properties and is just a pressure system that's losing its rotation as it moves across the equator. And then the Coriolis forces on the other side of the equator are actually what destroy it almost immediately within miles of the equator.
Okay, before we continue, my first bottle of beer is actually empty, and I think I need to change to something harder today. So give me 1 minute.
I'm thinking I might go on to the tequila. We've got Morty Tom Tom and Flat Earth Subgenius Society claiming that the black hole thing's all fake, of course, because that's what they have to do. They have to claim everything's fake, because if any of it's real, then goodbye Flat Earth.
Okay, so the drink of my choice today is pretty much the cheapest sort of advocaat that I found in the store today. If you're not familiar with it, it's pretty much eggnog with booze.
Eggnog with booze.
Yep. We just call it Eierlikör, which means egg liquor.
I've never... The idea of eggnog, I don't think I want egg in my alcohol.
You get used to it. It has about the consistency of maple syrup.
Okay.
Are you ready for me to continue the video?
Continue.
Difference in speed would be clearly measurable, and yet it's not. It's all mathematics again. We already heard Vsauce tell us that math is not science because we invented it. In math, we decide what's true. Numbers are not even things. They aren't concrete. They are not even nouns. They are adjectives that describe things. No different than colors, really. You cannot show me green any more than you can show me 5. You can show me a green car.
Stop.
I can most certainly show you green because there's a particular wavelength of light that we describe as green.
First of all, we all have to agree first what green actually is.
Yeah, and
So
everyone
we can
has
say,
agreed that particular wavelength of light is green.
Exactly. We can agree those objects are all classified as green, and then we can analyze them in this case in terms of what light they are irradiating or reflecting or whatever. And then we see that they all reflect wavelengths in a certain bandwidth, right? At a certain wavelength or a spectrum of wavelengths. And then, we can show you, or we will in the future be able to take a look at, or to actually measure the irradiation coming from objects, and without actually seeing them, determine whether they are green or not.
And then he says that we can't show him 5. Well, again, I would disagree with that because at a base level, maths is the only thing that we can really show each other. I think if 2 alien civilizations ever encountered each other, maths would be the way that they would communicate because 5 electrons is going to be 5 electrons to whoever you're showing it to. So,
Right.
we, you know,
This
we
goes
can,
back to what he said
quantify
at the
things.
beginning. This goes back to what he said at the beginning about how we apply numbers. They're axioms. One, we have to understand and agree about what one represents, like almost philosophically. You know, when we say we have one of something, we're not talking about we have one Planck's length of something. You know, we're now quantifying an amount of mass or a number of something, or we're quantifying a collection of something and calling it a whole something, you know. And so if we meet a alien civilization, you're right, that math is going to be what we both understand. We'll start with math. We'll work from math to determine, language and whatnot from there. But we can't go anywhere without first agreeing on the basic principles of math.
Oh, wait a second. To the side chat. Don't actually time out Gary Wibanga until, or unless he says something racist or something. If he just says something stupid, please don't actually time him out, because the more stupid or fluffs we document, the better.
Yeah. Can you hit me with a wrench, Gio?
Oh yeah, sure. Did you actually have to type something in the side chat so I can know that?
I would like to point out that Heat Shield made a great comment. 5 green tennis balls. Boom. Jaren's mind blown. But I mean, he's almost right. If he knew what he was talking about, he would be almost right. But he's not, because he doesn't know what he's talking about. He's trying to read what philosophical mathematics, philosophical sciences say about I believe the word is epistemology, how we come up with the concepts of 1 and 0 and things like that. We ultimately have to accept these things because they have practical applications in reality. You know, we accept the concept of 1 because it offers us a way of coming up with the number 5. How do we know the number 5 is the number 5? When we're looking at 5 tennis balls, how do we know 5 of them are there? Because we understand the concept of 1. And then we can understand how quantifying or how adding that up, changes the quantified, how much is there. But we have to understand the concept of 1 before we can understand the concept of 5.
Exactly. Obviously, when you're talking about numeral systems, this is pretty much arbitrary that our numeral system is base 10, right?
Yeah.
So this aspect of mathematics is just arbitrary, and it's probably caused by the fact that we have 5 fingers, right? If we had 6 fingers per hand on average, then we would probably have a base 12 or a base 6 system, which is what some
it would make sense to us.
Had. Well,
yeah, and it would make sense to us.
Not 6 fingers. But yeah, so this aspect is pretty much arbitrary.
The adjective there, and you can show me 5 apples, which is just an adjective and a way of describing a set of apples. But math is just a human invention, and much like the elephant earlier, math can be manipulated in so many ways to show us something is true, because, well, we say it is. Here's a quote by...
That's not right either. It has to have predictive capabilities. If the math explains a predictive phenomenon, then we can use that math until it's been proven to be wrong.
Tesla, talking about the reality of mathematical equations, he said, and I quote, "The scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality."
Stop.
Right, just one question. Did Nikola Tesla think the Earth was flat?
Nope.
Well, then can he fucking stop trying to quote?
Maybe in his later years, he got a little weird at the end of his life.
I'm still pretty sure he didn't think the Earth was flat.
No,
I mean, I know he created the induction motor without knowing what electrons were, but not the point.
I think he had alternative theories on gravity, not necessarily the shape of the planet. I wouldn't be surprised if he considered the possibility, but I don't think he was dumb enough to deny the observations of the sunrise and stuff.
Yeah.
So, I mean, the basic observation, when you talk about scientists of this caliber, I highly doubt there's even 5 scientists across the face of the planet that are of his caliber that believe that the Earth could possibly be flat. So I don't think he would as well. But what he's talking about here is he's talking about the emergence of quantum mechanics during his time. He's not talking about like general sciences. You know, he's talking about the theoretical sciences that were just coming out in the 20s.
Yeah.
And now we have practical applications like the modern transistor, the quantum eraser experiment. Just there's different experiments now that we can actually use that were not available during his time. So who knows if he would even would have said the same thing today as he said back in 1910 and 1920.
Yes. For example, just take a look at relativity, right? The first experimental confirmation of this was a solar eclipse, which I think happened in 1916. Correct me if I'm wrong.
I'm not sure when that eclipse happened. I know which one you're talking about, but I'm not sure.
It was basically they predicted the actual movement, or well, how far the stars close to the sun would be away from their usual positions as a result of the drag of the sun, or pretty much the bending of space-time of the sun would cause the light rays from those stars to bend, and therefore the apparent position of the stars to change when seen from Earth. So
well, not to mention, we accidentally proved general relativity several years ago with the satellites that we put into orbit, the Galilean satellites. They were put into an elliptical orbit instead of a circular orbit, and the clocks they had 2 options here. They could trash the satellite because the satellite at that point was useless. It couldn't be used for GPS. So they said, okay, instead of trashing the satellite, let's go ahead and use its very, very, very highly accurate clock on there, the atomic clock it has, and let's test its rate of ticking as it gets closest to the Earth and then as it gets the furthest away from the Earth. In other words, when it's at its deepest part of the gravity well, from the time that it's at its, the furthest point away from its gravity well. And then what they did is they did it. Guess what? They got to within 1/1000% of what Einstein predicted would be the rate of change due to general relativity. And this was an accidental find. This wasn't something we meant to do. This was something we messed up on as a human species and said, oh shit, look, we messed up, but we can still use this satellite to conduct an experiment. We did that.
So apparently someone in the side chat called Harry Warp actually found the article, and apparently Tesla was talking about atomic power and radiation.
Of course he was.
So it might be a quote mine. I actually want to look this up myself before I want to say this definitely.
Yeah, I haven't done research on the actual quote. I just know that he had his issues with quantum mechanics, just like Einstein did. Him and Einstein both kind of agreed that quantum mechanics was not, there was something weird about it. But Tesla agreed with it for different
distance.
That's what Einstein. The uncertainty principle.
Yeah, both of them, I believe, were materialistic. Came from the philosophical sciences of materialism, which means you can't have action at a distance. Everything has to be point-to-point reactions.
That was from his Radio Power Will Revolutionize the World, July 1934 article in Modern Mechanics and Inventions. We can simply look at centrifugal versus centripetal force to see another glaring example, and we can find more of the quote-unquote tricks of the trade.
Stop.
Centrifugal force.
Okay, I just want to warn the audience that now it's gonna get very good.
Yes.
Okay, so before you continue, his definitions, they are actually correct. Just want to say that.
The moving or tending to move away from the center versus centripetal force, which is the moving or tending to move towards the center. If you forget which is which, like I did for a while, an easy way to remember is to think of the F and the P. When I
How do you accidentally get those two confused? Just, I mean, that shows your lack of any kind of understanding of physics whatsoever to accidentally to say, oh yeah, at one point I did think the centripetal force was the one that was pushing me out, not bringing me in.
Well, I mean, obviously you can mix the words out accidentally. That might actually happen, but if you fuck up the two concepts, if you mix up the two concepts, then yes, something wrong in your thinking.
Yeah.
F, I think of flying off or flying away, and when I see the P, I think of
No, I see. I think I understand, and this is not to be stopping on the semantics. He's doing this. He's making himself look stupid for the wrong reason. He didn't have to throw in that anecdotal statement. He could have just said the easy way to remember it is not, oh yeah, sometimes I'm a dumbass and I misunderstand the concepts and think centripetal force means throwing me off. Well, then you've never studied physics beyond the 10th grade level.
But the reason why he's doing that is because, again, in his mind, it's an amazing discovery that if everyone else did, they'd be as smart as he was. That's why he's bringing it up. Oh, look what I figured out all on my special own. And now everyone else can copy me and be as brilliant as I am. That's why he's bringing it up.
Yeah. But, sorry, I didn't want to point that out. He's just
towards the center. So maybe that will help you a little as well. Now watch the trick here. The formula for centrifugal force is the centrifugal force equals the mass times the velocity.
Do you guys see what's bugging me about this? I'm just splitting hairs here, but this is already making me cringe.
What am I missing there?
Why the fuck is F not capitalized?
Good point. Yeah,
we're talking about force. That's usually a capital F instead of a small f, which the small f is actually usually used to when you're talking about the frequency. Usually the frequency is a small f.
That's probably a mistake that I would make, to be fair, just because I'm really bad at proofreading stuff.
I think
this can happen, but in this case, I would be very careful about that.
Yeah.
Because obviously, the frequency is a thing about the equations we're talking about. So mixing those two up in that case would be bad. It would be bad. So what I'm telling you now is confidential.
Squared over the radius. And the answer is in newtons. And the formula for the centripetal force is force equals mass times the velocity squared over the radius. And the answer is in newtons. Wait. Aren't they the same? One for the force flying out and away, and then the other is the force pulling inward?
Stop.
Then you might...
So, apparently Jeranism doesn't understand how reference frames work.
Nope. Are you surprised?
Nah, not really, no.
I mean, I don't think he understands how shoelaces work, to be fair. But
see, I'd seen this part, and I was going to say it a second ago when he was talking about the definition of centrifugal and centripetal force. And he's right, but there's also a point that you have to add in a reference frame, because outside of the reference frame, there's no real force that's actually pulling in or pushing out. I mean, there is in the case of gravity, but gravity is the centripetal force inside of the reference frame. And your desire to go outward is your centrifugal force in the reference frame. Outside of the reference frame, it looks like you're just trying to continue to move forward. It doesn't look like you're actually going around in a circle.
Exactly. It's a consequence of Newton's first law and the object's inertia.
Yes.
In the general theory of relativity, that it just so happens that gravity and the centrifugal force are equivalent. In order for something to stay still while on a spinning platform like a merry-go-round, they say that all the forces need to add up to a zero vector. Well, to do that, you need the fly-away force to equal the pulling-in force. So when you include our weight, which they say is because of gravity, then you can start to see the mathematical tricks involved.
Stop. That's only the case for an orbit.
Right.
The case when the centrifugal force, which is caused by the Earth's rotation, or by the movement of the object, and the centripetal force, which would be the gravitational force, would be identical. This would only happen for an orbit. However, when you're standing on the surface of the planet, you're not orbiting. The centripetal force, which is the gravitational force, is actually bigger than the centrifugal force, which is why you actually feel gravity pulling you down. In an orbit, no matter how close you are to actually the center of gravity, you won't feel that.
Right. Exactly.
Because you're in free fall.
Exactly, because the
yeah.
two forces equal out.
That's right. And they'll never understand that. They will never get that point. And that's why I was trying to explain that why we know gravity exists. This is one of the absolute proofs that an accelerating force towards the center of the Earth does exist. There's no other way to explain it when you're in free fall. If you weren't in free fall, or if there was no force pulling you down, well, you would just continue out. But let's just say that for some reason you were able to orbit without the gravitational force pulling you in, then you would be feeling the centrifugal force throwing you out. There's no you would never be in free fall. You would then be forced to the outside of the spaceship if you were orbiting, let's say, at the ISS. Because you wouldn't have a centripetal force, you would only have the centrifugal force.
Yep. You can continue.
Go right out the window. Really, Jaron, doesn't science require our sense of observation and depend on our senses? Nope, not even close. Let's let Neil deGrasse Tyson tell us so we are all clear here about science and our senses.
Yeah, that's so what you learn when you study science in general, but astrophysics especially, that you no longer invoke your senses to judge what
I was saying.
Or you no longer invoke your personal philosophies to judge what should be true.
Stop. You no longer involve your personal philosophies to judge what should be true. What he's saying there is, don't rely on common sense in science because the universe is fucking weird.
Yeah.
Right? Quantum physics is fucking weird.
Now,
objects can move through energy barriers in a way that is impossible in standard kinetics, because time is dilated by gravitational sources and by speed. Don't rely on common sense because it doesn't help you. And because the data shows that things are true which are completely counterintuitive.
Yep. I mean, we know that quantum mechanics can make data transfer faster than the speed of light, which we know breaks a whole bunch of laws.
Well,
okay, so
it doesn't.
Well,
but it can appear that way.
It can appear that way, yeah, but it actually doesn't.
Okay, so a few people have tried to say that centrifugal force does exist. So let's explain something to everybody. Centrifugal force is a fictitious force. It doesn't actually exist. It can be measured, but it doesn't actually exist. And the reason we know it doesn't actually exist is because, let's say you're spinning an object around your head, okay, and you clip the line. The centrifugal force doesn't pull the object away from you. It continues on its tangential velocity.
What's actually happening is you, the observer, are pulled away from the object in question. You are accelerated in a centripetal way away from the object.
Yeah, inside of it,
relative to the
outside
object, you can still measure the force, right? There's still a net force you can measure, but it's not the object that's being pulled out. It's you that's being pulled in. That's the difference.
Yeah, the that force, it's measurable inside of the reference frame. Outside of the reference frame, it's literally just going straight. It's trying to go straight all the time. It's trying to conserve its inertia. Or I guess that wouldn't be. Would it be right to say conserve inertia, or just trying to maintain its inertia?
Conserve its momentum, I'd say.
Yeah, conserve its momentum. Yeah. So let me get back to the camera.
FTFE, do you want to add anything?
No, I'm okay. Sorry, right there. I'm just waiting to hear how they misuse
Neil,
Neil deGrasse
we are
Tyson.
no longer to use our senses to judge what makes sense. The universe is what it is and doesn't care about your senses.
Yeah,
and we can start to see why. Because they have built the universe mathematically.
Jaron's exactly right there. The universe doesn't give a damn about your senses. It doesn't matter what your senses think. The universe is still going to be there according to the laws of physics that we understand.
Yeah, and well, there are two things about this. If he's literally talking about our senses, then yeah, that's why we built fucking instruments. right? This is why we use telescopes, because the angular resolution of those is much better than the angular resolution of my eyes. Heck, my eyes are so fucked. I can't even see my own balls without my glasses. And yeah, that is a sad truth.
And that's just where they don't understand. Carry on. It annoys me so much.
Yeah, Space Comma says it does exist because the reference frame exists. I already said you can measure it, but it's a fictitious force. When you remove the centripetal force, the centrifugal force does not pull the object away in the direction of the centrifugal force. So it's not a real force. It's not a force like putting your hand on an object and pushing it. That's a contact force. That's a real force.
Yeah, because again, it's not the object that's being pulled outward, it's you that's being pulled inward.
Yeah, I think Space Comma is trying to say because within a reference frame it can be measured. You know, it is a thing. Yeah. Yeah.
Yes, you can measure it, but it is a fictitious force.
And you take away that reference frame and there's no longer anything happening.
All right. So,
and only those skilled in those
You're
equations that have been
semantics
made
with me,
up
Space
are
Comma.
equipped to explain the world, how the universe they built using the math they constructed works. No deception can possibly work there. Because if you begin to invoke our own senses and to question what they have built, scary things begin to happen as the world they built begins to show signs of being a worldview, a religion masked by mathematical fact. We've all been had, ladies and gentlemen. Our senses can just watch the infamous spinning merry-go-round of death or the gravitron and see that when spinning, you will fly off the merry-go-round.
But does he bother to actually measure the or calculate the forces that are in play in what he's showing right now?
Right.
I can guarantee that the centripetal force there is way more than what we're experiencing on Earth.
And it's also more than what those guys can actually bring up against it, right? They cannot literally hold with them using their muscles by grabbing something inside this merry-go-round there to actually counteract the centrifugal force that they are feeling.
Yeah, and that merry-go-round that they're on is going to be spinning at probably like, I don't know, above 60 RPM. And that is so much faster than the Earth. You can't compare the two.
Yeah, I think we actually need to calculate this. Should we?
Go on then.
Okay, wait, I need to calculate this. So give me 1 second. I'm grabbing my good old trusty Casio calculator. Okay, so radius of this thing, what do you think?
I'm saying the radius is probably 1.5 meters.
No, I think it's less. It's
Less?
probably 1 meter.
Meter? Okay.
Okay, so plugging this into my calculation. Can you see my screen? So I'm going for acceleration then, because obviously we don't know the mass of those guys. So the way you get the acceleration is just cancel out m. Okay? Yeah. So we have 1 meter, which is r, multiplied by...
You'll say about 100.
2 pi divided by t. 1 second per rotation, maybe?
Yeah, I'd say about 60 RPM sounds right.
Okay, so 1.
Are you talking about how fast they're going?
I'm talking about their...
I don't think it's 1 time per second. I think they're traveling faster than that. Once they get that merry-go-round going, I think it's probably about 4 or 5 times a second.
No, can you maybe just run it a little bit?
Yeah, I'd say maybe 2 at the most. I mean, there's still a lot of mass on there that has to be...
Okay, let's just say 2 rotations per
and if
second.
there's no padded walls in the gravitron, well, you'd fly off that as well. We can read this article about the spinning merry-go-round of death, and this guy uses math to show why the man...
Yeah, okay.
3 rotations per second.
Yeah.
3 rotations per second.
So 2 pi divided by 0.3333. That should do this entire thing squared. So 1 multiplied by 2 pi divided by 0.3333, and that's squared. That is, a button, 355 meters per square second. Is that possible?
Oh,
It's
shit.
in meters. Could be, but that would be like 10G.
Yeah.
Oh,
Right.
hey,
No, that's not possible.
Sly just posted a centrifugal force calculator that will
Okay,
do it all fast
then
for us
just
online.
in case there's some fuckery going on with my.
So we said 1 meter, right? 1 meter
Wait a
radius.
second. I'm doing it live. Fuck it. Let's do it live.
Fuck it. Let's do it live.
Come on. There we go. Radius. Meter. 1 meter. Angular speed. Hertz. 3 hertz. Mass, let's say 100 kilograms. Calculate. Newtons, kilogram meters per square second. Can we do this? Acceleration. Yeah, 36G. Holy shit.
Yeah, they would have to, if they were able to hold on, they would black out relatively quickly.
Okay, now let's compare this to the Earth. So that's 6371000 meters. Angular speed in degrees per hour. So that's 15 degrees per hour. Mass 100 kilograms. Calculate, as we said, 0.0034 G.
Yeah.
Yep, 0.3%.
So when he tries to compare, what was the other one? 35G.
So wait a second. Is he literally off by a factor of 10,000?
Yeah, very, very much so. But that's the thing. They just don't understand. They have the basic understanding of what the maths should mean, but they don't have the concept of the numbers.
I was showing the wrong person. Okay, so this is the calculation for the Earth. 6,371 kilometers, 15 degrees per hour, 100 kilograms gives us a centrifugal acceleration of 0.0034 G. And 1 meter, 3 hertz, 100 kilograms. Yeah, 100 kilograms, 3 hertz, 3 rotations per second, 1 meter radius, 36 G. So he's off by the factor of 10,000.
A lot.
Sweet Jesus.
Someone in the chat wants you to just zoom in on that a sec.
Okay, so again, this is for this case, and for the Earth, 6371000 meters. Degrees per hour 15, same mass. There we go. 0.0034 G. And again, 1 meter, 3 rotations per second, 36 G. Off by the factor of approximately 10,000.
So that's good for Jism, though, right?
He's close.
I mean, this is probably better than every other flat Earth calculation that has ever been performed before. Comparison that has ever been done before.
But you know what? It doesn't matter because mass isn't reality.
Oh yeah, I forgot.
Mass and weight are the same thing.
Yeah, exactly. Angular rotation and
10 to the
centripetal
negative
force
17th is a negative number.
And space is a negative pressure system below 0 psi.
Yeah.
Like I kept asking him
conceptually. Hold on, I was thinking about this conceptually, right? And when you think of pressure, it's force per unit area. Okay,
Yeah.
So to have negative pressure would mean that you have negative force, which physically just means force in the opposite direction from your perspective, right? So you don't really have a negative force, you just have a difference in potentials. You still have the force. The force is still positive, but it's just in the opposite direction. Like I wasn't thinking of it as pressure, I was just thinking of it as force. So there is no such thing as negative force. I mean, negative pressure, I mean.
Yeah.
It's just a pressure differential.
I agree with SciFDK in the side chat. Apparently, just doesn't understand that the radius is actually what is important here. Should we do the calculation for 3 hertz at the radius of the planet?
Yeah.
I was going to suggest that. Do that at 3 RPM or 3 RPSs at 6,371 kilometer radius.
Okay.
Holy crap.
2.3.
It started displaying in hexadecimal.
2.3 times 10 to the power of 8 G. So yeah, that would pretty much fly you off into space immediately.
Yeah.
But then again,
What's the
that would
linear
have to be-
speed?
Yeah.
Does it give you the linear speed for that?
Well, it would be 75,000 miles per second, wouldn't it?
Oh yeah, that's right, because we're doing 3 revolutions per second. It's 75,000 miles per second. Yeah, that's pretty cool.
Wait, correct me if I'm wrong, but isn't this like literally like 20% or so of the speed of light?
Yeah, I know it's faster than that. What's 186,000 miles? Or no, 300. No, it's 300,000 kilometers. It's 186,000 miles, right?
It's starting to be accurate with Daniel Pratt's scaled down spinning ball.
We're at 0.4 C, I think, is if I'm doing the math right in my head.
Yes,
we're about 0.4
like
C.
this. Yep. So yeah.
So now we got time dilation that's occurring. Oh God, this is getting great. Good job, Jeranism. You ready?
Yep.
While only going at a linear velocity of 16 miles per hour. He even tells us here why it's a fake force. The actual acceleration, he tells us, is towards the middle. Again, to stay on, we need balanced forces, which the Earth, of course, has, we're told. He says in his article in regards to fake forces, and this is where the fake force comes in. Fake forces are not interactions between two objects. Instead, they are make-believe forces that we need in order to make objects in an accelerating frame behave as though they were in a non-accelerating frame.
Pause it. See, his issue and the issue of a lot of our flurfers here is words that are used. Fictitious, theory. You know, they take the words literally and just stick with the meaning that they have in their childish little world. They don't realize that outside of childish nonsense, that these words actually have an application within science and mean different things.
Okay, so
I think I know what happened.
Continue. Actually, think about what he just said, and remember that for later because it will become important. He's just saying that the centrifugal force isn't the thing. Is that fair to say that he's claiming that?
Mm-hmm.
Okay, just keep that in mind for later.
Well, I was going to say, when he hears people tell him, hey, Jeranism, the flat earth is fictitious. It's fake. And then he goes, oh, that's what fictitious means. And then he goes and he sees this guy talking about fictitious forces, and he goes, oh, man, that means they're fake forces. They don't exist.
And that's the point. It's like, and then they say, oh, gravity is only a theory, because they don't understand that within science, theory actually has, it's a weighty thing. A scientific theory is very, very different from the common vernacular usage of just saying theory. But because the word theory is there, they get all confused and in a dither and don't really know how to take it.
Okay, I think you can continue.
Newtonian mechanics in a place where it doesn't really work. He says, everyone has experienced these fake forces. Here you are in a moving car. The car turns to the left, and what happens? You get pushed to the right side of the car. Now, what force was it that pushed you? Or better yet, what object interacted with you? Surprise, there was no object pushing you that way. You want to say there is a force, even though there isn't one. This is the essence of the fake force. And yet, everything flies towards the outside. Fake car was turning in a constant circle, you'd be pushed towards the outside. When the spinning merry-go-round of death is going around, the person flies off to the outside. We see it every day, everywhere. But here's a place where, again, because of Newton's description of what a force actually is, it changes the reality. So now you have to believe that we are being pulled towards the center. They actually teach this to children. Check out this site and let me read to you how they explain this one, and we can all laugh at it together, and hopefully you can start to see why I say there's no possible way that we're spinning.
We're all laughing
so the site
at you.
is called the Physics.
The only people that's getting laughed at is Jaron here, right?
Oh yeah. No, he's completely
I'd
wrong.
say fluffs in general.
Gio, Seif said he wants to see one more calculation. 1,000. He wants to know the forces exerted on 1,000 miles per hour around a 1 meter radius.
God damn it! I just closed that window.
I got it open. I'll hold on.
Okay, then you just do it, I guess.
Gary, Webb, and Emblem. That's exactly the opposite. Stop saying such stupid things, because the outside surface is moving relative to what?
Oh my God! There's that exerts 20,378.5. I don't know if that's Oh, that was the
Can you
acceleration.
maybe just
Okay.
pull it onto the. So
199,845 newtons. So
What's that in G?
200,000 newtons. Huh?
What's that in G? Can you just maybe share your window?
Yeah. Well, it's going to take me off my camera.
Wait a second. I'm just gonna find it. It must be somewhere.
That's off of that calc tool that
Oh, there we go.
that-
I got it.
Sly pulled up.
Okay, my screen. So what did
Yeah, I
we
put
say?
1
We
kilogram
said
too.
1 meter. We said linear speed
1,000.
1,000 miles per hour. Mass 100 kilograms.
Oh, y'all had 100. I had 1. It's going to
Okay,
be whatever I said
20,000
times.
20,000 G. Obviously, we can change this value however we want because the number in G will stay identical,
Yeah.
as you can see. Because I actually prefer talking about the acceleration, not the force. Because this way we don't actually have to talk about the mass of the object in question.
Yeah.
Because mass and weight are
20,000.
the same thing.
Yeah, they are. They're the same thing.
And he can prove it, apparently.
Oh, I cannot wait. I cannot wait. I held my tongue. I was like, we're going to bring you back because when we bring you back, we're going to have that discussion.
Yeah.
Mass and weight being the same thing. You're going to have to severely try to prove that to me.
My God, that video you sent me of him, team, when he's standing there in the lab coat with the pens in the pocket, trying to act like he's a teacher. I actually wanted to punch my screen.
So here's a fun fact about lab coats. When they're clean, you're not working properly. Like the ones that I have, they have all holes in them because of I got some acid spillage or solvent spillage on them at one point or another, and they have like blue paint dots at the pockets because I forgot to put the lid on to the pencil that I was using. They have scratches, they have burn marks because that's what they have
The
for.
blood of your enemies.
No, not yet. I actually managed to bleach this one out pretty effectively every now
Cool.
and then.
Right.
But
Bleach gets out blood. Good to know.
By the way, chlorine dioxide, just saying.
Right. Excellent. Perfect. I know that.
But if you want to get rid of the evidence regarding the body, there's nothing better than a mixture of sulfuric acid and hydrogen peroxide.
Thank you. Notes taken.
Good.
This is, I guess, for children. It starts out talking about acceleration, then gives the geometric proof of inward acceleration. But we're going to go down a little bit further here so we can see an experiment or a test. So let me read you this from direction of the acceleration vector. It says, objects moving in circles at constant speed accelerate towards the center of the circle. The acceleration of an object is often measured using a device known as an accelerometer. A simple accelerometer consists of an object immersed in a fluid such as water. Consider a sealed jar that is filled with water. A cork attached to the lid by a string can serve as an accelerometer. To test the direction of acceleration for an object moving in a circle, the jar can be inverted and attached to the end of a short section of a wooden 2x4. A second accelerometer constructed in the same manner can be attached to the opposite end of the 2x4. If the 2x4 and accelerometers are clamped to a rotating platform and spun in a circle, the direction of the acceleration can be clearly seen by the direction of the lean of the corks. As the cork-water combination spins in a circle, the cork leans towards the center of a circle. The least massive of the two objects always leans in the direction of the acceleration.
Least dense, I believe, is what he means. Right? There wouldn't be the least massive, it'd be the least dense.
Yeah, obviously we're talking about the density here.
I don't know what article he's reading from, but if he read from that article and it says mass, I think that's a pretty shitty article to
Sorry, I had to nip out for a second there. What did I miss?
Well, he said that the more massive object will go to the outside, which I don't think is true. I don't think it's mass that determines what will go outside. I think it's density that determines that because you're generating a force, and the force is determined by the displacement of what, like the buoyant force.
Yeah, also what you're talking about here, obviously the water itself is decoupled from the acceleration, and that's the point. The water itself wants to keep in a straight line in accordance to Newton's law. But the cylinder, the glass cylinder around it, that's what's being accelerated inwards, right? That's what's being pushed by just the friction with, or the, whether it's glued or just standing on there, doesn't really matter, with the board. So what's happening is that the glass container is actually being pushed inside, which leads to the water being pushed against the glass cylinder. And since this is happening, the cork is actually being pushed to the inside because the water is trying to displace it. Therefore, the cork is actually pointing in the direction of the actual acceleration, which is pointing inwards.
And that's where he's getting confused. He thinks that it should all be pushing outwards because of it's spinning. He's not taking into account, all the everything else that's involved and the reason why the cork would be going inwards.
That's funny. We asked them to explain the vector of acceleration, that they say that all their densities align, right? And they say, "Oh, well, it doesn't need one. What are you talking about? You assign that to it." And here, he's explaining exactly what we're talking about.
Yes, I was about to say exactly this. This is actually a good demonstration on why we know acceleration in terms of gravity is a thing. Because here, before this system is accelerated, the cork will not feel a force to the inside or the outside. But as soon as an acceleration, in this case caused by the rotation of the system, starts being applied onto the cork, there will be a displacement and therefore buoyancy that starts to happen with the cork. And this is why it's being pushed inwards. Ergo, an acceleration must take place in order for the cork to move at all, which is why we know that density alone can't be responsible to the phenomena that we observe today or on the surface of the planet all the time, right?
Yes, exactly. If there was no accelerating force, regardless of the different densities, the relative densities, both of them would just, once you let go of them, they would both remain in the exact place they were at, minus any internal motion. Let's say we remove all internal motion and we just look at the the dispersion of what they would do is they were static at the molecular level. So at the molecular level, all we have is the gravitational force to pull down. Well, it pulls down with more force on the denser object than it does on the less dense object. So those forces, because there's more force of pulling on the more dense object, it displaces the less dense object. It doesn't mean that it's not pulling down on the less dense object. It's still pulling down on the less dense object. That object is still under gravitational acceleration, but it's being displaced outward further away by the more dense substance that's being pulled with more force towards the surface.
But no, team, a helium balloon defies gravity, so you're wrong.
Yeah, I'm sure we'll get to that when we talk to those other two guys again.
To the cork in the water, the cork is less massive on a per milliliter basis, and thus it experiences the great.
Okay, so there he did correct it there, massive per milliliter. So again, he could have just left all that out and said more dense.
Acceleration. Having less inertia, owing to its smaller mass on a per milliliter basis, the cork resists the acceleration the least and thus leans to the inside of the jar towards the center of the circle. This is the observable evidence that an object moving in a circular motion at constant speed experiences an acceleration that is directed towards the center of the circle. This is complete nonsense. The water is being pushed to the outside, just like in the gravitron, just like in the merry-go-round of death, just like in any merry-go-round, just like in anything spinning. The water is flying towards the outside, which is pushing the lighter cork towards the middle. This here.
Can we put Jeranism in a merry-go-round of death?
Wait a second. The water is flying outside, so he's now acknowledging that the centrifugal force is a thing, while before he said it was just fictitious.
Yeah.
So he just 180'd on that one.
He doesn't even realize he's 180 though. That's the thing. He still thinks that he's making the same point.
Yeah, when it's convenient, they say it doesn't exist. When it's convenient to say it does exist, it does. Just like I don't know, he's getting a lot of things wrong. So we'll just keep going forward.
He says the cork of the water accelerometer points inward towards the center of the circle when placed upon this rotating platform, thus indicating an inward acceleration for circular motion.
Stop.
Wow.
Okay, so imagine that you have this accelerometer, right? This cork and a string inside a glass vessel filled with water, right? Okay.
Okay.
What happens if you just put a cord around it, just a wire, and then you pull it towards you in any direction linearly? What will happen?
Towards you. It travels towards you.
Yeah, exactly. And what will happen with a cork?
If you pull on it.
If you pull the entire vessel towards you.
Oh, what will happen to the cork?
Yep.
In water, it'll come to the front of the. It'll come closer to you than the water.
Exactly. It will come closer to you because the water, which has more inertia, because it has more density per volume area, will actually take longer. It will take more force to be accelerated in your direction. Therefore, the direction of the movement of the cork relative to the glass container is the direction in which the force is applied.
Yes.
There we go.
Same thing happens when you accelerate in a car with a helium balloon. The helium balloon goes forward.
Seen it.
A little bit further here. It says another simple homemade accelerometer involves a lit candle centered vertically in the middle of an open air glass. If the glass is held level and it rests, such as there is no acceleration, then the candle flame extends in an upward direction. Okay, correct. However, if you hold the glass candle system with an outstretched arm and spin in a circle at a constant rate, such that the flame experiences an acceleration, then the candle flame will no longer extend vertically upwards. Instead, the flame deflects from its upright position. This signifies that there is an acceleration when the flame moves in a circular at a constant speed. No, again, the flame is being pushed towards you because the heavier air is being pushed out. Complete and total nonsense. Look down here. It says, thus far we have seen a geometric proof and two real-world demonstrations of this.
So for the candle accelerometer, obviously the same applies, right? If you pull it towards you, the air will take a longer time. It will need more force to actually be accelerated in your direction. Therefore, the candle light flame will point in the direction of the acceleration. Therefore, if you do this in a rotating system, the same applies, and the direction in which the candle light is pointing will be the direction of the acceleration.
Acceleration. At this point,
same basic explanation for every single thing you brought up.
Pretty much, yes.
Becomes the decision of the student to believe or not to believe. What? So it's up to the student. And then look over here. There's a happy little student, and she says, "I believe in physics."
Wait a second. This is teacher talk of saying either the children get it or they're just dumb as fuck.
Wonder which one Jeranism is.
He should finally release his grades.
I saw something directed me by Saif. He said he has a pickle to pick with me. Hold on, let me shut my phone off for a second. It says I never mentioned Cavendish. Yeah, we didn't get to that. We will, like I said, Saif, we have another hangout with him planned in a couple of days that we'll cover a few other things. It'll be more of a structured hangout where we'll have more planning in that one.
Wait a second. So two people are apparently talking to Nathan Oakley. Is he in the side chat? Or am I missing something here? Are they just talking about...
Monty Tom just said Nathan Oakley for some reason.
Yeah, okay, whatever.
Maybe that's just what he shouts when he orgasms.
Saying here that when something is on a spinning platform, that it's being accelerated towards the middle. And the evidence they give is this rotating platform, which clearly shows that the water is being pushed to the outside.
Yeah, stop again. Repeat the experiment. Repeat the experiment with a linear acceleration, and you will see what we're talking about.
No, he won't. That's the thing. He won't see what we're talking about. He will still misunderstand it and think it proves the flat Earth.
I think I need even more.
In each hand, and you outstretched your arms and started spinning. The milk would not fly towards you in the middle. It would fly towards the outer edges of the carton. However, according to this, the fact that the air in the bottle would come towards you proves inward acceleration. Give me a break. I mean, the experiment they show is simply laughable at best. Of course, if you spin this turntable, the cork goes towards the middle. It is less dense than the water, which is being flung to the outside. All you need to know to see this
Yes, well
deception is
done.
how a centrifuge works. When you spin a centrifuge, the heaviest items, the items that are more dense, fly out, and the less dense items come in. Not because there's an inward force, no. So this is for the Wikipedia from centrifuge, and it says a centrifuge is a piece of equipment that puts an object in rotation around a fixed axis.
Stop.
Spins it in a circle. Okay, so far we're on the right page.
Stop.
Applying a force.
How can they read the definitions of stuff and then still get it so wrong?
Yeah, it's pretty incredible, isn't it?
What did you want to say about them?
So the centrifuge. He apparently doesn't understand that the reason why we use centrifuges is pretty much to actually sort different fluids or a solid inside a fluid by the density. And he understands that without having an acceleration here, this wouldn't occur, right? There would be no sorting of the different objects with different densities. But yet he's not able to apply the same thing to gravity.
No. Just reading the side chat there, the reason Nathan Oakley's name was brought out because that is where Multi Tom Tom gets his scientific method from. Oh, brilliant.
Yeah, Sly, I believe you're right. It's what makes a buoyant force possible in a centrifuge. Once you have the outward acceleration, you can actually use that to get a different to use that. I'm sorry, my phone's ringing again. To get to separate the different densities of the plasma or whatever you're trying to separate. But Gio could probably talk better about that since he works with those.
I actually haven't used centrifuges in years. The last time I actually used one in the lab was when I was doing my bachelor's thesis. Because back then I was dealing with macromolecules, graphene oxide.
So now that you're done with your indoctrination, you don't use the tools of indoctrination anymore?
No. I'm not done with my indoctrination. Remember that I'm still waiting for the grade of my master thesis.
Yeah, he said you failed. Sorry.
Oh, fuck.
Have you signed your contract saying you'll promise never to tell the world the truth about real science?
Team, we're live. You can't talk about that when we're live.
Yeah, I cannot tell you that I have actually signed it yet.
Yeah,
it said it in the contract.
Well,
when I signed the contract, I promised that I wouldn't be talking about the fact that I was signing the con. Oh, fuck.
Yeah, just make sure you fill in the part about AT2 Productions paying you and everything.
Particular
Wait, are you saying that AT2 Productions shouldn't be paying me anyway?
They're not paying you?
Not yet.
They're not paying me either.
Oh, just me then.
God damn it. Give me my money, 82.
The centrifuge works using the sedimentation principle, where the centrifugal acceleration causes denser substances and particles to move outward in the radial direction. At the same time,
the acceleration causes sorting by density. I mean, he's right there, obviously, but yes, yet it doesn't snap in his brain that the same applies to gravity.
Oh, no, of course not.
It's the reason why we have the pressure gradient going up. There's less pressure going up because it's literally without gravity, you would have nothing pulling down on the system.
It's why when you take a density tower into the vomit comet, it disappears and isn't a density tower anymore.
I would really love to see if Flurfer talk to me face to face and say, I don't believe in gravity, and then just float the fuck away.
Yeah, I made that joke at the beginning of one of my videos. I would very much, if they hate gravity so much, just go away. Just float the fuck away. We don't care.
Without gravity, you could just uppercut them and they would never come back to the earth.
Oh, that would be so satisfying, right?
Maybe that's what the rapture is, just all the fluff going away.
I still think...
So now that they're gone, we can finally actually work on the properties of physics that need yet to be resolved.
I still think NASA should just take some of their budget and send all of the flat earthers up in a rocket just to show them the Earth. Don't bring them back or anything. Just let them stay up there.
I was just about to say, just accidentally in air quotes, forget the oxygen.
Yeah. Oh, NASA, you were right. It's lovely. Can you bring us back down now? NASA? Hello?
Houston to Fluff 1.
I just wonder if, like, 100 years
not
from
give
now,
you any oxygen because it would be just a waste anyway.
Yeah.
I just wonder, like, 100 years from now, if they'll ever even talk about how there was flat earthers.
Yes.
Yeah, no, in 100 years' time, there'll be the Flat Mars Society.
Oh God.
I don't care if your granddad came here.
Placed and moved towards the center. So again, do you see what they're doing here? They just described that exact action.
Will Earth just be a luminary at that point? Or will they say, will they accept that it's a planet? They might say, oh, it's flat. We just you look up, you only see one side of it all the time. It looks like a circle. It's flat.
So you believe the books that say we came from Earth?
Yeah.
It's actually causing a force. The cork, which is less dense than the water in the accelerometer, is coming towards the middle. No, it's because the heavier items are flying towards the outside. Now, they can't tell you that. Why not? Because you're going to start to question, how am I spinning on a spinning sphere? How am I not flying towards the outside? All the heavy items in a centrifuge, in a merry-go-round of death.
Now it's time to actually calculate the gravitational acceleration, I think.
For what?
For the Earth.
Oh, yeah, that's always fun.
Okay, so share. So do you see this equation here?
Which one?
Oh,
yes.
wait. There we go. Now I should be sharing my screen.
It's the same equation every time.
No. This one, gravitational force.
Oh, okay.
Okay, so when we're talking about gravitational acceleration, we can just forget about this m because it will just cancel out with this m. Therefore, A equals g times big M times r squared. So what we need is just the mass of the Earth.
Big.
Just Google this one. So it's 5.972 times 10 to the 24 kilograms. Let's plug that in. So, and we obviously need g. Gravitational.
But G's just a religion.
6 points. So I'm doing the calculation on my calculator. So 6.67 408 times 10 to the minus 11, and the unit is cubic meters per kilogram per square second. So multiplied by the mass of the planet, which is 5.972 times 10 to the 24 kilograms, divided by 6371000 meters squared. And any predictions on what we're gonna end up with? Come on, you know that one.
Sorry.
What was the mass we were putting, or you were doing what now?
The gravitational acceleration on the surface of the planet.
Oh, well, I don't know. It could be 9.8 meters per second squared, or...
Yep. My exact result is 9.8196497338, and I challenge you all in the audience to repeat that if you don't.
Well, Sleeping Warrior did it, and he got -3 ice creams.
That was what his mom/girlfriend gave him.
So yeah, again, there's an approximate 0.3%. We calculated the acceleration in g before, and we were at 0.3% of g. But I saw you just calculated.
No, I think Saif, I think the number we came out with was 0.003, which was 0.03%. I think that I wasn't doing the calculation.
The number that was shown was in g, not in meters per square second.
Oh, Elon Musk is in the chat, and he asked if we saw the Event Horizon image. Yeah, we did. It was beautiful.
I doubt that that's the real Elon Musk.
Oh, of course it's the real Elon Musk.
And if it's the real Elon Musk, well, two things. First of all, I like cars. But I would really love to have a HUD, a head-up display in the driver's seat just for the speed, because I don't like looking in the middle on this awesome but yet a little bit badly placed screen just to know my speed.
And also, can I have a place on the special spaceship that is for the Illuminati?
Can you reduce the price of the flamethrowers?
Oh, they sold out. It was a one-time thing, man.
Oh my God.
I know.
I have to buy them secondhand from somebody. I'm just making my own. Okay.
Today in Texas, a fire took out 3 villages.
and
Yeah.
also, can you please make a hatchback version of the Model 3? I mean, it's just a little bit too long for European cities. If it was the form factor of a Golf, then maybe I would buy one.
What?
But on the other hand, VW is currently preparing the sale of their first completely electric car anyway. So hurry up or you won't get my money.
I very much like my hybrid Ionics, but my next one would definitely be full electric.
Take the VW ID3. You'll love it.
Hey, Gio, did you see Siphon thing? He wants to know how it went when you tried to teach Riley chemistry.
Oh, sorry, I've just noticed that Riley has released a video directed at me.
I love that answer.
Wait,
on a scale of 0 to 10, how hard was it?
Let's see. So I actually am still sub to Riley.
Yeah, this where in the world is George Musser, Craig, the author of the article he keeps using, who I've been in constant contact with, and we're organizing Project Aristophanes together for Sleeping Warrior Week, which begins May the 20th. So I'm going to be having the interview with George Musser, episodes about him, and then we're doing Project Aristophanes, which is 4 points across America, getting angles of the sun and using it to calculate the circumference of the planet. So yes, Sleeping Warrior, it's all coming, don't you worry.
Aaron Massa said open source flamethrowers. Yes, open source.
Oh, beautiful.
All right, let me go ahead and play. I'm looking for, there it is.
Gravitron. All those items are pushing the heavier and most dense items to the outside. But on the Earth, it's the opposite. All the heavy items are pulled towards the inside, and the gases and the atmosphere is being pushed to the outside. It makes no sense. The heavier items get pushed to the outside in a centrifuge, which would be me, you, rocks, water. Those things would be flying towards the outside, and the lighter things, like the cork, or in this case, the atmosphere, would be pulled to the inside. It truly becomes more and more insane the further you go. If we go to Cool Cosmos and ask why don't...
All right. Hey, I see you and Sly talking on the side. I think Sly's right, but I think being 3,266 times weaker than G is 0.3%.
Okay, let's do this calculation again. I'm just
trying to do it off the top of my head.
Okay, I'm doing the calculation here. Okay, so obviously we're talking about the acceleration here, so I'm just gonna cancel this entire thing out and gonna cancel that one out, and we end up with 9.81 meters per square second, and here we used those ones. Okay, so R equals 637,71000 meters multiplied by 2 pi divided by 24 times 60 times 60 seconds. And this entire thing squared. Okay? Correct so far?
Yeah.
Okay, so 637,100 times that one. So 2 pi divided by 24 times 60 times 60. Obviously, we need the entire thing in seconds. Squared equals 0.03 meters per square second. And let's just, if you think this is approximately 10, then this would be approximately 0.003 G, which is approximately 1/300 of G.
Do the actual math to, it came out to 0.03 meters per second. Okay.
Yep.
Because he's looking at centrifugal force.
So yeah,
not
obviously, if
centrifugal
you have the force
acceleration.
just multiplied with the mass of the object, but if
it comes
mass
out to the
are
same
identical
because you're-
anyway, it will, yeah, you will end up
Yeah.
with the same ratio. So yeah, Sly, you were wrong by a factor of 10. Ah, there we go. Sly stands corrected. Okay.
God, it's why I love people like Sly Sparkane. It's why I love people like you and Sean and Fight the Flat Earth. Good up on you, man. You're so much better, Sly Sparkane. Right now, you just showed so much more fucking intellectual integrity than any flat earther ever. Okay. Oops, I had one extra zero. He admitted his mistake. It was that
They
simple,
can't do
flat
that.
earthers. It is that simple. Just admit your mistake and learn from it, and everything will be okay. Don't fucking double down on your mistake and say, no, everybody else is wrong because of indoctrination, because you guys don't know. You've just been taught that in school. No, just admit your mistake and everything's good.
Yes, it's like, I know shit happens. He apparently just put into his calculator 1 0 too much when it came to the radius of the planet. So yeah, I immediately saw that there was something fishy going on. So yeah, with
The
that
Earth
met
moved.
result, let's just continue.
Earth spins very fast, but we don't feel the motion because it's constant. Okay. It says the spinning and orbital speeds stay the same, so we don't feel any acceleration or deceleration. You can only feel motion if your speed changes. Anyone
Yeah,
ever been on the gravitron? Did you feel anything?
Exactly. You only feel acceleration. You don't feel speed.
Yep.
That's the point. And you can convert your speed in the gravitron, or however it's called, into the centripetal acceleration that you actually can feel.
But 1,000 miles an hour. But 1,000,000 miles an hour, Geo.
But 666 and a tilt of the Earth, and it's also convenient, Geo. It's isn't it convenient that all your equations match reality? Isn't it convenient?
Oh, that's just reverse engineered.
When you talk to them, they suffer from so much cognitive dissonance. They put it out so frequently that they're like, yeah, so you should only feel acceleration. You shouldn't feel speed. And you're like, well, why don't you apply that to when you're moving through the galaxy, but you're moving at 1,000,000 miles an hour?
I mean, we could
okay.
do the calculations for the centripetal force on the entire solar system on its way through the galaxy around the supermassive black hole.
Can we just address something in the chat? Gary Webenembanga says apparently we've just changed the distance to Polaris.
Yeah, maybe if there's a more accurate parallax measurement coming in, then yeah, maybe. I don't know. I mean, there's always this uncertainty. When you read the distance to Polaris, it will say plus or minus that amount. And this just means that if the measurement is correct, then the actual resolution of the measuring system that we use would imply these inaccuracies. Right? And when we use a new instrument, then obviously, first of all, we would only use a new technique if this technique promises better results. If the new technique plugs out better numbers, then, better numbers. If the new technique promises more accurate results, then we're gonna use that one. And if it delivers different results, then yeah, we're gonna go with those because we know that they will be more reliable.
And Gary, let me tell you something. The fact that they're changing they're updating the distance to Polaris means that we're actually doing science out there. If we'd never updated it, if we always said, no, it's the same number as it was 2,000 years ago, and we never gave any data to support that, then you'd have an argument to bitch about. What we've done is we've essentially, why, from a flat earther's perspective, why would we have put out the wrong information for so long only to change it today? If it wasn't the fact that our math and our instruments and the limits of our technology only allowed it us to measure it with a certain accuracy, and now we have better technology to measure it with that better accuracy, we can give it a different value. We give it a value that's different from before. Why would we do that? That makes us look stupid if the flat Earth, if the Earth's really flat. But that's because
Okay,
it's not
and
flat,
apparently he's wrong. So he says it's the first result when Googling for the distance of Polaris. The first one I found was a distance of 433 plus or minus 27 light years, which is approximately 132 plus or minus 8 parsecs. Maybe you're talking the distance in parsecs instead of light years.
I mean, either way, if they change it, that's still, it validates our argument. We argue that science makes changes all the time when we have a better understanding of what we're doing. If we were lying about it all the time, we'd have no reason to change that value, ever.
Beep, of course you did. You were flying to the outside. Let's go to Earth's sky. We asked the same question, and we are reminded of one little thing that we forgot to discuss in our merry-go-round example. It says we don't feel the motion because you and everything else, including the oceans and the atmosphere, are all spinning with the Earth at the same constant speed. Do you see the nonsense yet? Now the atmosphere is spinning with the Earth. At Alaska, it spins at 500 miles per hour.
Why is he saying it like that's a new discovery?
Let's first of all, let's just assume that we had a spinning planet with a stationary atmosphere around it. What's the first thing that would happen?
Sorry, say again.
Okay, so you have a spinning planet, but the atmosphere around it is not rotating with it. What would happen?
What you'd feel like you were in a constant wind.
Yeah, pretty much you'd be blown off your feet instantly.
Yeah.
And then what would happen over time is as the atmosphere has certain viscosity to it, right? As the atmosphere has friction going on with the ground, with the surface of the planet, be it liquid, be it the ocean, or be it mountain ranges or just solid land. It would actually, there would be an exchange of momentum, right? Where the rotation of the planet would actually slow down a tiny little bit, but it would accelerate the atmosphere to actually be dragged along with it. That's what drag is, and this is why we expect the atmosphere to rotate with the planet. And which is also why, when you take a look at gas planets, the actual wind speeds that are possible there are much higher than on the surface of terrestrial planets, because there's just no solid surface to have an interaction with.
Yep, carry on.
Sorry, I'm getting to it.
Spins at 1,037 miles per hour at the equator and 860 miles per hour in Los Angeles. Wow, what an amazing atmosphere indeed. But clouds and winds can move around with no problem while the entire atmosphere is magically attached to the spinning Earth at the speed of sound.
Stop.
It's simple.
Okay, can you move to the front of an airplane while the airplane is at cruising altitude?
Yes.
Okay, is the airplane moving at 1,000 kilometers per hour?
Well, depends on which plane, and
Yeah,
it can be. Yes.
Let's just say Boeing 737 MAX 8. No, wait, that one's lying on the ground. I forgot. Oh yeah, let's just say cruising speed for commercial aircraft. Let's say 1,000 kilometers per hour.
Yep.
Somewhere along those ranges. Now, the speed that you are walking to the front of the airplane is approximately 4 to 5 kilometers per hour.
Yep.
Is that possible?
Yes, because speed is relative.
Yeah, there we go.
Why is that such a hard concept to understand? Well, he keeps saying 1,000 miles an hour.
Yeah, and he says that things are flying faster than the speed of sound, not their airspeed. They're not.
Yeah, because the speed of sound is another thing that's relative, right?
Yeah, the speed of sound is what's relative. If you're moving at or if you're moving in an atmosphere, let's say with the winds, the high speed winds, and you're inside of those high speed winds, well, the mechanical sound wave propagation is relative to the medium it's traveling in. So if that medium is moving 700 miles, or I guess in the case that he was saying 250 miles per hour, well, then the speed of sound relative to the ground is the speed of sound plus 250 miles per hour. But that's relative to the ground. Relative to the wind around it, relative to the atmosphere around it, it's still moving at the speed of sound.
Yeah, and the speed of sound in the water is a lot quicker, and the speed of sound through a metal is even quicker. The speed of sound is an entirely relative thing based on where you are, what speed you're going, and what you're in.
Right. The speed of sound means nothing without much more information given to be able to deduce what that quantitative value is.
But it's not even the speed of sound that you have to think about. It's just the fact that they keep saying this 1,000 miles an hour. The Earth is spinning at 1,000 miles an hour. Yeah, but relative to what?
Relative to the center of the Earth?
But
well, no, relative to a stationary coordinate system around the Earth.
It just doesn't work.
You guys ready?
Yeah.
Yep.
Ridiculous. To go even further with the deception, they now turn to the airplane example. If you were traveling on a plane, you don't feel it. You don't feel you're moving. Yeah, because the plane has a roof. What if we removed the top of the plane? Would you notice then? Of course you would. You would be dead. The article
there we go. The problem is just that there is nothing that the Earth's atmosphere can have friction with, because there's a vacuum. Doesn't he understand this?
He does. He clearly understands it, but he just keeps spouting this because he can't not at this point.
Oh, dear.
Line is that we don't feel the Earth rotate because Earth spins steadily and moves at a constant rate in orbit around the sun, carrying you as a passenger with it. So where is the top of our plane? To believe that the atmosphere just spins freely, always knowing what speed to spin, is simply insanity. And again, even
what does he mean by knowing? Does he imply there that it's somewhat conscious?
I guess he's saying conservation of momentum is conscious now.
Yeah, no, it isn't.
No, it's not. Yeah, he's an idiot.
Did have a roof, all the things that are the heaviest would be pushed to the outside of that roof, not to the inside, not towards the spinning ball Earth. If you look here, this is a video of me traveling with cruise control for 1 mile at 50 miles per hour. So let's pretend that we are on a merry-go-round at a spot where we spin at a linear speed of 50 miles per hour. Okay, it's pretty fast. But now imagine that we take a plane or travel to the equator. Are you ready to see what 1,000 miles per hour looks like? Here we go. Imagine that we are at the outside edge of a merry-go-round traveling 25,000 miles in a day, which equals 1,000 miles per hour. Well, here is that ridiculous speed.
Stop.
I mean, we'd be flung up.
I mean, obviously, he's using the parallax angle to the close objects in front of his camera.
Yeah.
Which, if you're actually sitting in an airplane, you look outside to any objects in the distance, right? Mountain ranges, coastlines, whatever. The parallax angle change per unit time will be much smaller than what we are seeing here.
Not to mention, let's go ahead and look right here. We're literally watching with this still image right here. We are watching everything moving at 1,000 miles per hour in unison. It could be moving at 500 miles per hour. It could be moving at 10 million miles per hour. But in this still frame, we are showing this all moving together as one, in one frame of reference. So there is no, it doesn't matter the 1,000 miles per hour. In this example that he's showing, let me show you what it looks like. No, that's wrong because you're showing that relative to a stationary ground. You're not showing what we see. And the 1,000 miles per hour, everything is moving at 1,000 miles per hour at the equator. Not just you, not just the wind. Everything is the ground, the grass, the air, everything.
In 2 seconds, and imagine if I had a trough of water with me, it would be completely gone. Now you have to imagine that the atmosphere is moving along with it at this speed. How? This is ridiculous, and clearly we would feel this edge linear velocity. But by making
clearly we don't.
Now, and
We already did the math on why you wouldn't feel this.
Expect to feel it. That's the point.
Right. 0.03% of what we are being pulled down with, and what we feel is that force. We feel a combination of all those forces added together. That's one force of acceleration that we feel. When you have just 0.3% pulling you up, that means you're only losing you're weighing 99.7% of what you weighed without taking into account the centrifugal force.
Earth, a giant sphere, saying it exists in a vacuum with an attached atmosphere that spins in concert with the ground below it, perfectly at the same speed as the ground, is patently absurd. That we wouldn't feel this speed or be able to detect it with our precise measuring devices is simply insanity.
Two things. First of all, yeah, we can actually detect it. For example, the irony is strong with this one. First of all, we can detect the 15 degrees of rotation per hour, and one of your buddies has done that.
Good, Bob.
With a rather
wait, that was confidential.
Hey, boob.
Rather accurate scientific instrument. Second of all, we can actually determine the orbital velocity of the planet Earth by actually taking a look at the redshift of stars near the ecliptic. Because when you take a look at a star near the ecliptic, at one point in the orbit, the Earth will approximately move towards it at a certain speed, which we can measure via the blue shift of the star. And half a year later, we will see that same thing happen, only with a redshift. But the delta V that we see here, right? The amount of red or blue shift will be identical for both points in time, only pointing to the different direction of the movement. And we can actually do the same with, for example, well, we can do the same with the rotation of the planet itself, right? Because obviously any telescope that sees this will feel both effects simultaneously. So you actually have to count for one, if you know what I'm saying. You do understand that, right?
Yes.
Sorry, I've been distracted by Sleeping Warrior.
No, I was listening. Yeah.
Carry on.
This is just
pay attention, Craig.
Yeah. And as I said, you are free to believe the math that says it's possible, just as you can believe that the elephant can hang from the tree branch off the cliff. Be my guest. Believe you are spinning as we speak.
Is anyone going to help the elephant?
This this elephant has probably listened to Jeranism and now tries to hang himself.
Yeah, no, it's all gravity's not real. So he's like, oh, no problem, I can get this.
Yeah, I got this. It's only density.
Yeah, my weight and mass are the same thing, so I don't need to worry.
Floating along in outer space at such a perfect consistency that can't be felt, and it no longer even matters what speeds or equations they invent. We'd never feel it.
Hold on. We do feel it. We've actually measured the centrifugal force using standardized weights and measurements. Like we weighs differently as you go further away. It weighs more as you go further away from the equator. This is a direct evidence to the rotation of the Earth.
The best way actually is to measure it using a pendulum. When you're on the equator, obviously the gravitational attraction to the planet will be counteracted to a certain degree by the centrifugal force.
Right.
Now,
0.03% or
yeah, whatever. Now the swinging period, right? The time it takes for a pendulum to swing once is only dependent on the length of the pendulum and on the acceleration that it's feeling. So you can actually do very precise measurements only using obviously the length of the pendulum is known, and you can measure like 1,000 times it's swinging back and forth and measure the time it takes for those 1,000 swings to actually take place, and using this equation derive the acceleration that it's feeling. And if you repeat this once on the equator, once at the different latitudes, basically, you will immediately see that you will have more of a net acceleration towards the planet the further north or the further south or the further away you go from the equator.
Yeah.
By the way, this is the Erdos effect, literally.
Tell you that you're flying through space at 89 trillion miles per hour. You can't tell. You're traveling in a plane and simply can't tell. Let's discuss for a second the atmosphere spinning with the Earth. So imagine if you stand here with this column of air above you, that as you travel, the air moves exactly with you. Where would this end? If space is above you and the atmosphere is altitude, where does it?
It ends when the atmosphere ends.
Well,
what's the issue there?
Basically, it ends where the rotational speed of the atmosphere at that altitude would become the orbital speed.
Well, there you go, Jeranism. There's your answer.
Spinning with you. If you sent a balloon up, eventually wouldn't the Earth spin out from below you? Well, we know this doesn't happen. If a helicopter were to hover above the ground, is it gravity that carries the helicopter along with it at 1,000 miles per hour?
No, you fucking idiots. It's friction with the atmosphere.
Yeah, I was just going to say that.
Yes, this way it's very easy to say, of course we don't know we're spinning because we always have been and always will be. We and the atmosphere and the helicopter all have inertia. It's absolute crazy talk. It's a religion. It's simply a belief. The other answer that they have is the almighty gravity. This is the answer.
Yep, gravity.
About the balloon. What was he saying about the balloon and its inertia?
No idea.
That the Earth would spin out from underneath it.
The thing about the balloon is, obviously, you will not get close to anywhere the height you would be that you would need to actually determine on where the border is, because balloons pop at 40 kilometers or so max.
All right, I just didn't hear what he said. I want to make sure.
To all the globe issues. Good old gravity, the weakest force holding everything on Earth to the ball as it spins and flies through space, holding the atmosphere, holding the oceans, the hills, the lakes, the rocks, the hovering helicopter, and the airplane being carried backward as it flies west. All of it controlled by action.
If he just actually learned the equation, the law of gravity, and its implications, then all his questions would be answered. He literally, if he understood what that equation can help us predict and do, and how it relates to literally everything else, then it wouldn't be an issue. But he won't ever actually learn it, because that means paying attention to the model he's trying to debunk.
I think I'm going to replace God in my lexicon with Newton. So I'm like, oh my Newton.
Well, here's the thing. We can actually prove that Newton existed.
And guess when his birthday is, guys?
Oh, it's 24th of December, isn't it?
Happy Newtonmas.
Yeah, happy Newtonmas. Newtonmas. That's what we're going to call it, Newtonmas.
Just before... Sorry, carry on.
Well, it's on Christmas
Math
Day.
works.
Yeah, it's on Christmas.
Newton's mathematical equations for gravity. He wrote tons of books and gave us the formulas. Really? Well, I wonder what Newton had to say about his gravity equation and how it relates to reality.
Okay, so for the audience, this is where the first part of his video ends and the second one talking about Newton starts. So just a little bit of a topic change. You may continue.
Yeah. We go from math to space here, right?
Yeah.
Here's Newton in his own words in a letter to Bentley telling us what he felt about gravity or this action at a distance.
Warning, biggest misrepresentation of a quote probably in this entire video. Coming up very soon.
He said, quote, "It is inconceivable that inanimate brute matter should, without the mediation of something else which is not material, operate upon and affect other matter without mutual contact, as it must do if gravitation, in the sense of Epicurus, be essential and inherent in it. And this is one reason why I desired you would not ascribe innate gravity to me, that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of something else, by and through which their action and force may be conveyed from one to the other, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Gravity must be caused by an agent acting constantly according to certain laws, but whether this agent be material or immaterial, I have left that to the consideration of my readers."
Stop.
Right. Yep. So Newton had no idea about what gravity was. That wasn't the point. Newton gave us the equations of how to, figure out the gravitational acceleration and everything. Newton didn't care about what was actually causing it.
Well, I have to correct you there. He did care. He just didn't have the means to find the answer.
Yeah. Whereas now we know that, thanks to Einstein and general relativity, that it's the literal warping of space-time, changing the locality of things that manifest as an accelerating force.
Yes, and this is what he's saying in his last sentence. Gravity must be caused by an agent acting constantly according to certain laws. And he just didn't know that laws. He didn't know what actually caused the forces he could measure. He's not saying that his equation that he derived for gravity was unreliable in any way, sort of form. He just said that we know that it works. We just don't know why it works.
Yeah.
And I'd like to point out that this right here is a fork in the road that anybody can approach and attempt to master. Okay, if Jeranism wants to master the explanation of what gravity is, because I still do not get to this day why they do not accept that an accelerating force is there. Whether they want to accept the fact that it's mass attracting mass, whether they want to accept the fact that it's a flat Earth flying up at 9.8 meters per second squared, whether they want to accept the fact that it's electromagnetism, who figure that out. But there is an accelerating force, and it's caused by something. Newton stopped with what he understood right here. This is where Einstein picked up. If you think you can do better than Einstein, pick up from here and prove Einstein wrong. Show how you can make better predictions than what's predicted by general relativity.
Yeah, there's still a lot we don't know. We don't know exactly why mass warps space-time.
Yes, we don't know a lot of stuff about gravity. For example, we do not know yet whether it has an exchange particle. Right, the graviton is hypothesized, but we actually haven't measured it yet. Or we haven't seen it yet, or found it yet.
So, there is a lot still that we don't know, but that doesn't mean that what we do know is wrong, because it, again, can be used to make predictions about the universe that are always right.
Yeah, and again, Newton was pretty fucking close.
Oh, yeah.
Obviously, he didn't know yet about the extreme cases that we actually find regarding relativistic effects, right? He didn't know yet about how or he didn't know yet that you cannot extrapolate your speed infinitely into the fast, right? You cannot you cannot accelerate and just increase your speed linearly. He did not know that when you reach a certain point, you will not get faster, you will get heavier. Well, both actually simultaneously, but the faster you go, the more you will become heavy, and the less you will go faster.
I mean, there's also things like he didn't realize that he thought gravity propagated instantly.
Yeah.
Whereas we know now that it propagates at the speed of light.
Yes, if the sun despawned right now, we would still continue orbiting around it for 8 minutes.
Yeah, exactly. We wouldn't know anything for 8 minutes.
Yep. If the sun collapsed to a black hole right now, we would still see the sun's light coming in for the next 8 minutes.
Oh, Jaron. I mean, that what he's reading there actually disproves everything that he said, but he doesn't understand that.
Well, Newton also didn't know that light has a finite speed.
Yeah.
For example. That came in later. The first measurement, I think, about this was done using the moons of Jupiter. Aligning or predicting the time at which solar eclipses on Jupiter would happen, and seeing that when you actually were in conjunction with the planet, they would happen a few minutes earlier than expected. Oh, well, I think it's the other way around, right? If you were on the other side of the sun compared to Jupiter, the solar eclipses would happen 16 minutes later than expected.
Yeah.
Because you are 2 astronomical units further away from the planet than at conjunction.
Big numbers, they won't get it.
Have his name attached to the ridiculous notion that were his mathematical equations, but today he is praised and celebrated for inventing the math that allows these nonsensical beliefs. And here's another article from a physics website that asks again why we can't feel the spin of the Earth, and here's their answer. So why can't we all feel it? The answer lies in the nature of Earth's movement. Think of being on an aeroplane with it smoothly traveling at a constant speed and constant altitude. You've unbuckled your seatbelt to go on a walk down the aisle, but you can't feel the movement of the plane. The reason is simple. You, the plane, and everything inside it is all traveling at the same speed. In order to perceive the movement on the plane, you have to glance at the clouds outside. Again, remember what we talked about earlier? This plane has a roof, and that's why it's able to be moved with everything inside it at the same speed. But we'll get to that in a second. It says it's the same with the Earth's rotation, except for the fact that the Earth has no lid. It has no ceiling to the plane. Our planet completes a full turn around its axis every 23 hours, 56 minutes, spinning incessantly at an almost entirely constant rate. Notice again, it's not constant, and that's why they have to say spinning at an almost entirely constant, even though they tell us that the reason we can't feel the spin of the Earth is because it's moving at a constant speed. Here, not entirely constant. One way to feel motion is to feel wind on your face, but remember that the Earth's atmosphere is traveling with us at the same speed. Do you see the deception yet? Do you see how easy it is to just say, oh, well, everything's moving at the same speed, therefore it's the same as us traveling inside of a plane, when it's completely and totally different. A little bit further down, it says, so why does Earth spin so constantly? Because there's nothing stopping it. And now you understand why there has to be a vacuum of space, why it has to be a vacuum, because the Earth...
No, why it is a vacuum. Not why it has to be a vacuum. Why it is, how we know it's a vacuum. I mean,
exactly. This is how I would phrase it. How do we know that the Earth is traveling through a vacuum? Well, simple. Because if there wasn't a vacuum, we would feel the effects of drag on the Earth and on the atmosphere.
Right. Absolutely right. And this is what they think happens with the luminiferous ether. They think that light in one direction is experiencing drag from the ether. And that's why when you're traveling around the sun and you're trying to do these measurements, you're always getting the same, you're always getting a measurement as if you're in a constant, you're not moving. You're getting the answer as if you're not moving, but it's all relativistic, They say, oh, well, this is because there should be an ether wind that's slowing the light down, when actually we're traveling away from the mirror that it's reflecting on.
Basically, let me try to describe it. If there was something like an ether, then photons traveling in the direction of your movement through that ether would feel ether drag.
Yeah, exactly.
And comparing this to the movement of the photons, for example, perpendicular to your direction of movement, you would feel that the ether-dragged photons would travel slower or at different speed than the ones that aren't affected by this. And this is what they tried to find and what they didn't find, because the ether isn't a thing.
Right. Just like there's no drag in space, there is no atmosphere in space for us to drag against. So we travel effortlessly through it.
To spin through it and has nothing stop it. Again, the easy answer is we don't spin. Do people understand that yet? It gets rid of all the other assumptions. Again, when our solar system formed out of a collapsing dust cloud and spun out into a flattened accretion disk with a bulge in the middle, all the planets inherited that rotation. Again, we've always been spinning. We've always been flying. That's why we can't feel it. What an easy way out for science and mathematics. And yet again, they return to the airplane example, even though this has nothing to do with how we live on Earth. We are told men can take a space shuttle or rocket out to space. Can we shoot a rocket to space from inside a passenger jet? Of course not. It's contained. It has walls and a floor and a ceiling. But on space...
What does that mean? Like, how does that make it?
I don't know. I'm drowning. At the point is he's just waffling.
I mean, he realizes that we do have planes that are able to fire rockets, right?
Yeah, I was about to say, just because we don't do that doesn't mean it's physically impossible to shoot a rocket off of a plane into space. We can do that.
Actually, there's some stuff in development right now where you actually try to save a little bit of rocket fuel by lifting the rocket up into the stratosphere with a carrier plane. Doesn't seem to be working so far, but it might be a way to go forward.
That would be cool.
Elon Musk just said, yeah, okay, we'll do that.
Cheers, bud.
Yeah, thanks, bro.
Where's the ceiling? And the other problem that arises, and you can see it discussed at length here at Stack Exchange because it disrupts everything that we are told, is why is it easier to walk from the front of a plane to the back and more difficult to walk from the back to the front? Anyone who has ever been on a train will tell you that. But look at all the fighting and name calling.
Stop, no.
Just no.
If you were blindfolded and you were walking inside a train moving at a constant speed, you wouldn't feel the difference on whether you are going in the direction of the train traveling or in the opposite direction.
No, except when you got to the front and they asked for your first class ticket, you'd know then.
So yeah, the idea on the train that they have a hard time is because you do feel the train moving because the train is actually bumping along the tracks. So that to them, they try to use that and say, well, that doesn't make sense. I know which way the train is traveling. I can feel it under my feet. I can look outside and see the trees passing by. If we set up an experiment and we put two boxes next to each other, right, in a completely blacked out room, and we said these two boxes are moving at constant speed, which one, what speed are they moving at? Well, you couldn't tell. Without something to compare those two moving, you couldn't tell. Even if you had one box moving 10 miles an hour faster than the other box, all you could say from that is that box A was moving 10 miles per hour faster than box B. You wouldn't be able to say what they're actually moving faster or the actual speeds they're moving relative to another position. Now, let's say you turned on all the lights and now you have a large tunnel that's marked with mile markers. And now you say, oh, well, now we can calculate. Now that we have these markers, we know exactly how fast each object is going. But then you have to say, no, you don't, because you don't know how fast the tunnel's moving. So you got to, once you add the tunnel's movements into the whole thing, then you can add another speed relative to something else. So just saying that, that you can feel something when you're in a train. No, you can't. You cannot tell. If you take that hypothetical situation and we say, remove all the external factors, remove the environment around the train, remove the tracks, keep the train going at the same speed and in the same direction, but remove all access to outside of the train and remove the train tracks so you don't feel the bumps. And you will not, under any circumstance, be able to tell how fast you're going or in what direction you're traveling. Anybody else think, or should I keep going?
Keep going.
Why? Because if it were true that we traveling on Earth is the same as a plane, then there should be no difference in the direction you walk on the plane or train. But there is. And so like the plane, it should be easier for us to walk west than east. When an Olympic athlete runs a 100-meter dash or participates in a long jump competition, they should all request to face west.
Wow. Oh, okay. So conservation of momentum is a thing. When you begin to go in one direction, you carry with yourself the direction you are going in the other, the velocity you are going in the other direction. So if you jump 20 miles an hour backwards off of a 60 mile per hour truck that's moving forwards, you're still moving forward at 40 miles per hour. And you know this because when you hit the ground, guess what? You roll backwards. You don't roll forward at 20 miles per hour. You roll backwards at 40 miles per hour. I'm from the country. I've tried this.
Of course you have.
Trust me.
That's an average Friday night.
You hold your momentum and it continues with you. Jumping east to west, west to east, north to south, pick a fucking direction. You're going to carry your momentum in any direction you jump. And unfortunately, you're going to get the same result. Anybody have anything to add to that?
No, I'm stunned by the stupid.
A faster speed and a longer jump, but you don't. Why? Well, because the Earth does not spin and it does not move.
Hey, Bjorn says, I wonder how long you feel the fall in the zero-G plane. You begin feeling it the moment that the plane goes into free fall. You begin to feel weightless. And
by the way, the start of free fall is not at the top of the curve. It's actually early.
Right.
It's basically if you imagine it like a sine curve, it's pretty much everything above the x-axis.
Okay.
So it's
So you feel it. You will be in that free fall until the plane stops your geodesic. I believe it's what's called your desire to continue to go straight. Once that acceleration begins, once you start slowing down to where you're no longer accelerating towards the Earth at 9.8 meters per second squared, that's when you will start feeling the gravitational pull.
Period. Now you can use some.
Yeah. Period.
If you want. You can believe the equations of men and simply trust and believe in them. That's always safe.
We don't just believe in them. We use them because they work.
We demonstrate that they are facts and describe our universe.
How much testing, how much lab work went into your master thesis?
Half a year of 8 hours per day.
Half a year, 8 hours per day. How much of that was just saying, oh, Professor so-and-so said this, so let me write this number down? And what if that's all you had to do? If all you had to do was recite the numbers the professors had told you that you were supposed to get, how quickly would you have gotten done with your master thesis?
Much quicker.
Right. You can't do it because you have to do lab work. You have to take scientific theories and apply them to real world applications and test those theories out. You test the theories out by saying, this is the prediction I'm making. And then you run the experiment and then you say, oh, you compare the two. If they were way off, you're not getting your thesis, bro.
What do they think scientists...
Fun fact about my thesis, I actually did approximately 1 chromatography column per day, sometimes 2.
Wow.
The record was 4.
Like, what do they think scientists do all day when they get to work? Do they just like party with champagne and hookers and blow and stuff? Like, scientists have to actually do their jobs.
I got it. They have their own Discord server where they agree on constants. That's what they do. They say, okay. Oh, hey guys, let's hold a Discord server poll. Does anybody want to change the distance to Polaris today?
I have a suggestion. Pi is exactly 3.
Yeah, let's put that through state.
Opinion. The answer to the question, do we spin, is actually quite easy. The answer is no. That's
he got it wrong. Did he not listen to us? We've just spent the past 3 hours telling him why he's wrong.
Yeah. Well, you said yes and he said no. So.
Oh, does that mean I'm wrong?
Time to hold a Discord poll. If everybody in the chat will type 1 if you think Fight the Flat Earth is wrong, or idiot if you think Jaren's wrong.
We're too busy making up some CGI pictures in an accretion disk.
Oh, the render time will be horrible.
Yeah.
On the other hand, Team Skeptic, you have a nice computer to render now, so you can do that.
Yeah, we can share it over mine and yours.
I love it. I rendered my entire 3-hour hangout from yesterday in like 18 minutes.
Ooh, nice.
And I was like, oh.
Remember, in about 3 months, there will be a CPU out there fitting in the same socket that will be 2.4 times faster than yours.
It's just, it'll fit onto my motherboard, the B450 Plus. Oh my God, I'm getting it. I tell you what,
it's $500 though, just saying.
Hold on, I want to address this. Middlewell, yeah, I don't mind being pointed out wrong. What did we get wrong about it? Because you said, do you listen? I don't pay attention to the chat too much because I'm operating the YouTube video. So do you care to point out what we got incorrect?
I think this is more of a general question. Like, how would we react when we are proven wrong? We would thank the person that corrects us. That's the point.
Yeah. There's actually 4 of my videos where in the description, I say I made a mistake and I've been corrected. Here is the correct information. And in the next video, I've said, I got this wrong in the previous video. This is actually what it is. I'd like to be corrected because I like to know when I'm getting stuff wrong.
Apparently,
this is the guy.
Submarines.
Right. This is the guy that thinks that me and you contradicted each other about how submarines work, because I stated that because of the fact that as pressure increases with depth, it squishes the hull, making the density of the submarine increase with the depth of the submarine, putting it in a natural state of an unstable equilibrium. That's just how it is, and any scuba diver will attest to this fact that this happens. Whereas in your video, you just kind of described the more basic mechanics of how a submarine surfaces and dives.
Yes, the first approximation you do is that the submarine has a given volume, and that the water around it has a given density. The water around it has a given density, but if you increase your depth, obviously you go squeeze the submarine and decrease the volume.
Yeah.
So yeah, that's the question here. And obviously, I actually
FTFE
don't know much about
wrong.
this FTFE, but at low depths, do you have to take the squeezing of the hull into account?
Yeah, constantly, because like I said, it puts you in a state of unstable equilibrium. So you're constantly trimming the tanks to maintain the ballast that you want. It's not quite as simple as pump some air out, bring more water in, stay at that depth. There is constant adjustments that have to be made to maintain that because of the natural state of unstable equilibrium.
We can actually bring a submariner in here if we need to. I believe Jay Brown is available.
He's just about to start a stream actually about submarines. And Milwaukee says FTFE says the diving comes to a natural stop. No, I've never said the diving comes to a natural stop. That if you bring more water into the ballast tanks to go down more, then that's what happens. But as you go down in depth, the density of the submarine increases, which puts you in a natural state of unstable equilibrium, which means you have to constantly adjust for what's going on. It's simple. It's not hard. But like I said, I explained about the unstable equilibrium.
Middlewell, you don't have to apologize, man. Anytime anybody has a question out there, please ask it, because I'm going to be the first person to tell you that a lot of times when I'm in a debate, when I'm trying to go 100 miles an hour, I'll make a mistake and I won't even realize it until I'll listen later and go, oh man. Like one of those I said when me and Nathan Thompson were debating, I said something about that taking 100 miles above the surface, we were talking about the difference in the gravitational force 100 miles above the surface. And then I said the radius of the Earth at 6,371 kilometers. I realized later that I made a contradiction. I was meaning 100 kilometers up. He used the term miles. I was trying to say 100 kilometers. You can use the 6371 to 6471 to explain the difference in gravitational pull, not the difference from 0 to 100 kilometers, because then that would be a big difference. So that's sometimes I do things, I make mistakes, and if you ever see something I make a mistake on, if you ever want me to explain more, I'm all for learning, and I can't learn without making a mistake and going back and saying, now I understand where I was wrong and how I was wrong. So I appreciate being corrected to ensure that I don't make the mistake moving forward.
But
so
what you said about the sub wasn't wrong. You very accurately described the way a sub dives and surfaces, but you didn't go much beyond that because that wasn't required. Whereas I explained about the unstable equilibrium and having to constantly adjust to maintain your depth.
Right.
So neither of us were wrong. I just kind of went a little bit further than you did. But for some reason, he's taken that as we have described different things. It's the same thing about Newton and Einstein. They actually described exactly the same thing, but in kind of different ways.
So without being a submariner, because I'm not a submariner, when I was in the Navy, I didn't spend time on a submarine. You're going to have hull compression, which is going to increase your atmospheric pressure on the inside, and you have to do something about that atmospheric pressure. So you force the atmospheric pressure into the compressed air tanks to take care of the compression of the sub. But that necessarily by itself won't allow it to go to the depths it needs to go to. So it has to fill the ballast tanks to attain the depths that crushing the hull necessarily wouldn't get you to. It wouldn't reduce your volume, or it wouldn't increase your mass enough for the volume. It wouldn't increase your density enough. That's how I understood it from the research I did. But I'm not a submariner, so if I got it wrong, by all means, tell me I got it wrong. But that's the way I understand that they attain the depths that they do. It's not simply by submarine compression.
Yeah, I think that he's just misunderstanding the connection between the way that both of us explained it.
Yeah, but hey, if I'm wrong ever, guys, please correct me, because that's what we're here for. We're all here for learning, and I'm never too old and too smart to continue learning.
But the Earth's still not flat. So
wait,
the Earth's still not flat, and it is spinning, guys.
Are you saying that you consider yourself smart?
Way smarter than you, and because you think water's made of H2O, and Peter and Pete proved us wrong about that. I've changed. It's just I now believe that air, hydrogen is now just a different gradient of air.
I figured out that hydrogen is just a heavier form of helium, and they're actually the same thing.
Oh, where's my suicide X when I need it?
Don't worry, I can order one from Elon Musk's website for you. Or actually, hey, Elon Musk, if you're still in the chat, can you please overnight GeoStriber a suicide axe, please?
And can you make more flamethrowers?
And make more flamethrowers.
Okay, I think we should continue. What do you think? How much is left of this video?
I think that's about it.
Yeah, we have, let me see. Oh, we have a minute left. Let's just let the video play out, and then we'll hang out after that.
Well, unless there's some more stupid that needs to be debunked.
Well, it's
because
got
I
a
think
minute.
I actually switched off the video at this point because I thought,
One, 2, and 3. I'll let you guys pick it. How many mistakes are we gonna find in the last minute?
9.
Craig, no, we have 1, 2, and 3. Craig, if you're in the chat, please type 1, 2, or 3 before we start. We want to know how many times you think Jaron's gonna make a mistake in this last minute.
I say actually more than 3.
Yeah, I'm going to say 3 because that's the biggest number I'm allowed.
Let's just assume that he wraps up the video by just repeating his points. That would mean that he's doing the same mistakes as before
no,
again.
Wait. He does a Patreon thing at the end, doesn't he?
Yeah, he does. So you guys are screwed.
Fuck.
But oh, look,
42.
42. Yeah, 30, I saw 33 in there earlier. Let's
my God, I thanks to the people in the chat constantly saying that, and people that are called Zaphoid Bibler Brox. I've actually started reading Hitchhiker's Guide again.
Barry on 33. That's who said 33. And then I want to point out something. Mike Bube, I think it said B-E-W-B. I'm just saying Bube because I think so. What was the mistake you pointed out that I acknowledged? Just so I can.
B-E-W-B.
Yeah.
I think that's supposed to be pronounced boob.
Oh.
It's boob.
But anyway, we'll keep going on. The answer is 0 because he has an outro.
Opinion, you are free to yours. Links to all the articles discussed are in the description.
I found a mistake.
It's not an opinion.
Yes. First of all, it's not an opinion. And second of all, in science, we are not free to have our opinions. That's the point.
Review process.
If there's a true scientific uncertainty about something, if there are two competing hypotheses, then yes, it's your opinion about which one is likely to be more correct. But that only applies if both of them are as yet unconfirmed. There's no preference for either of them. As soon as there is, you are not entitled to your opinion anymore.
Yeah. An opinion is something like red is my favorite color.
So that was 2 mistakes right there.
Okay, let's carry on.
Mike Boob said it's not pronounced as anything. It's an inside joke. Well, it's now an outside joke, and it's Mike Boob. I'm sorry, Mike, but oh yeah. Okay, yeah, you're right. It was me making a mistake on that. On the forces and accelerations. There's a few videos back, I believe.
Yeah.
But yeah, it's no longer your inside joke can remain inside. The outside joke is that it's Mike Boob.
You to do your own research, because if you do, you'll never again believe what you were taught. Please donate to this channel if you can. I need and appreciate all the support to keep this channel going. This has been Jeranism, and until next time.
Peace.
Bye, Jaron. See you next time.
He actually spoke, so that was mistake number 2. And he
number
said
3.
that okay, so that was mistake number 3. And he said he's going to make another video, mistake number 4.
And he
because every time you make a video, you look stupid.
We realized we've all been lied to. That was a mistake, because when we researched, we realized that physics is real.
And then I hate to the turtle moves had something so funny that he said earlier, and I stopped the chat to read it. Now I can't even remember what it was. But now that I see his name, I remember that I forgot.
Oh man.
Let's see. Such a good song for such a horrible content creator.
Yeah.
Totally wasted
Well,
on him.
horrible content creator. We have to differentiate here between two things. First of all, the production value of his video is obviously fine, but the content is just shit.
Yeah. Well, intro and outro of his videos are great. The rest of it isn't very flashy or interesting to watch or anything. He just put some text on the screen and read it. Because I reckon, he had nothing to do with the creation of his intro and outro, and then he just puts the basic shit in between.
Yeah.
I was saying I didn't make my intro. That was one of my friend's band, and my outro was made by Mr. Cheswick. Cheers, dude.
I made my intro.
Do you not think it's funny that I stole a Flat Earth song about me for my outro, though?
Dang, there's some. Oh, hey, I want to ask somebody, since we have people in here. I want to. I'm looking into this new live streaming platform. Have y'all seen that D Live?
No.
Okay, so there's a new streaming platform that apparently the people watching the streams make money watching it, make money interacting with the streamers, and all the streamers make money too.
Stop! Scam alert! This is highly. All my bells are ringing right now. There's something bogus about this.
I haven't promoted it yet because I'm trying to make sure. But I was like, I want to bring it up to talk about it because I was like, if this is true, because their promise is to never take any percentage of anything. So if somebody donates to you, they're not going to take the 35% that.
Yeah, wait a second. This means that you are not the customer, you are the product. They're probably selling all your data.
They own you.
It said it was a blockchain. It was done by blockchain, so it makes me think if maybe they're using your processing power.
Yeah, I was about to say that as soon as they're saying blockchain, this means that you're using your computing power to make Bitcoin or whatever.
Wait
a second, Team Skeptic. This means in the end you actually lose money because the extra power your computer needs to actually power this will increase your electricity bill in such a way that the income from whatever they're using will outweigh actually this.
I mean, I haven't done a lot of research into it. I just saw something about it yesterday, so it just took me by surprise that there was this new platform that was coming out. So I was like, oh shit, I want to look into it.
Bullshit. I'm calling scam right away.
Well, yeah, I'm not leaving YouTube. I love it here on YouTube.
Yeah, me too.
I think that flat Earth is probably dying out on YouTube. I find more flat Earth videos using a Bing search than I do using the Google search. Google is absolutely not promoting
the filters within YouTube search is turned off at the moment.
Yeah, I don't know that. Why did that happen?
Because they're trying to alter the algorithm to stop certain things happening, and I think it was mainly to do with stopping like things with kids coming up in the searches. But to figure it out, they figured we're just going to turn it off instead of letting everyone use a broken filter. So using the filter is useless, because I would go onto the filter and go flat Earth past 24 hours, and it would show me any flat Earth stuff that's come up in the past 24 hours. But now it doesn't work, and you have to go to Bing or something.
Yeah, I've just started using Bing for all the searches for flat Earth because Google doesn't want you seeing them.
Yeah,
and that's fine. That's their choice. Hey, I'm not mad at it. I'm not mad at Google. I'm not mad at YouTube. YouTube is a business. They've got to protect their business. If they think that not promoting the flat Earth to the people is best for their business, then I think that that's what they should do. But
and also from a moral standpoint, right?
Yeah.
Just saying.
From a what?
From a moral standpoint. But the same obviously applies for anti-vaxxers in particular.
Well, I think anti-vaxxers are a different topic. I think that they represent a true danger, like a human danger.
Obviously, they're much worse than flat earthers.
Yeah.
Yeah. So, but I don't think that we were discussing this last night in our hangout. I was like, should there be any regulation on teaching bad science? So let's say, right now, if I tell you, just drink orange juice and it'll cure your cancer. Well, that's making a medical claim that's obviously not founded by any medical studies and will lead to death. So don't replace chemotherapy with orange juice, guys. If you're out there,
Unless you really feel the urge to die.
yeah. So I can understand why there's regulations put in place to keep that from being allowed. Now, when you're doing what Jaron's doing, and we talked about earlier in this video too, he's not making an opinion. He says it's his opinion, but he's stating it as fact. So should there be any regulations put in place to keep people from teaching bad science? I mean, we have them for bad medicine.
I don't know.
I mean, it's a question.
Good question. Obviously, I agree with you. It's a good question on what type of information should be, well, not necessarily banned, but at least given a warning.
See, but the thing is that I also believe that the human adult should be able to watch Jeranism's video and go, yeah, this guy doesn't know what the fuck he's talking about.
Yeah.
So if you can't, then that's your problem. You know, that's something you have to deal with. So it's different with the anti-vaxxers, because the anti-vaxxers, if they can convince you to not do vaccines, you actually pose a health risk to yourself, your family, and the people in everybody around the world. So I can understand where there would be more regulations on that. But I think that the people in the chat here, for the most part, the people in the chat here, they're all able, without me, you, and Fight the Flat Earth pulling this video up and breaking down what he's got wrong about it, I think they could figure it out on their own. So I don't see the danger. I don't see the exact danger in this. I see the danger when you push it towards kids, or when you talk about kids not going to school, or you promote you start saying, oh, college is just indoctrination, don't do college. I think that's a fucking problem.
Yes, first of all, this homeschooling thing, this is something that just doesn't exist over here. Homeschooling in Germany is banned, full stop.
Well, homeschooling in the UK is completely up to the parents. And for me, there was a bit of time where I had to homeschool Struan, my son, because whilst we were waiting to get into our new home that was made for my disability, we were moved about quite a lot, and he's got severe ADHD, and him going in and out of schools would not have been good for him. So me and the school board decided that I would homeschool him for the time until we were settled. And I think that was the right thing to do. But I don't think just general homeschooling is the right thing to do.
Yeah. Well, like Midwell 531 says, the danger of flat Earth is to generally give science a bad name. And yes, I agree with you on that. Here's where I think the actual danger, if there's an actual danger that flat Earth poses, it's to this particular group right here, from 17 to 21. Those kids, or we'll say 16 to 21. Those are the kids that are at the point in their life where they're looking beyond high school and they're seeing college as an option. Okay, so when you're looking at these two options and you can say college, no college, we can all agree that to take the no college route is the route that has the least resistance. It's the route that looks like it's just so much easier to take, even though it's going to provide hardships in life. You don't see that. You only see the difficulty in front of you. And when you look at college, you then see a mountain. You say, I'm just getting out of high school. School is not what I want to do. And here is something that's even harder than what I just got through bitching about. So you have that right, that fork in the road. And then you have this jackass from the right going, yeah, everybody goes to college is indoctrinated. Yeah, those guys, they just repeat. They're just parroting. Stop believing everything. Close your eyes and trust your senses. That's where I see the problem becoming an actual danger to society, is when you start when you start telling people who are preparing themselves to take on an extremely hard venture in their life. In Gio's case, how long were you in college, Gio? Was it 6, 8 years?
University? 13
Yeah, no, I'm talking about from the time you started your college to right now, because as far as I'm concerned, you're still in your educational process. How long have you been going to college for?
13 semesters.
13 semesters. That's 6.5 years.
Yep.
6.5 years. What kind of fucking person wants to go to school for 6.5 years?
Well, wait,
Okay.
stop. School, wait, stop. Okay, I actually have to clarify this. In Germany, in order to visit the university, you have to pass a state exam before that, which is called an Abitur. Now, you have to go to school in Germany by law to the age of 15. Now, after the 4th grade, the children are separated into 3 different groups. The intelligent ones, the not so intelligent ones, and the dumb fucks. And sorry to my dumb fuck friends out there.
Flat earthers.
Yeah. No, well, those people are gonna end up in labor jobs, right? Like carpenter, that kind of thing. Not saying that all carpenters are stupid, because I actually have 2 carpenters in my family, and they are not stupid. But they're just not academically skilled, right? It's just not their field. The ones in the middle category, they will end up as state clerks, bank workers, this kind of thing. And the 3rd group, which I was in, they will go to a school called Gymnasium. And this is the only type of school that ends up giving you the Abitur exam, which happens at age 18, 19, or 20, depending on which state you are. I actually am one of the very first who did it after 12 years of school. Usually it was done after 13 years of school. And only if you pass that exam, you will be allowed to go to university. So I would actually count the amount of scientific education you need starting from either grade 10 or grade 11, because that's where this really starts kicking in.
Yeah.
To answer that question, yeah, it's possible to jump groups. You can actually change from one school to the other, but it's sometimes when you're going up a tier, it would require to repeat 1 year of the higher school, because obviously in the higher school more stuff is taught, so you need more time to actually catch up. And the way this is done is just by being downgraded by 1 year.
I need to address 3 comments in the chat. Starting with Bjorn Kamitz. Critical thinking is the best thing to teach, and I agree with that wholeheartedly. They should teach critical thinking from the moment that they put a child into school, and that's what gives us our ability to postulate new things that are not fantastical. Rentashiel says Germans have strict rules. They don't want things to go wild again. And the turtle moves. Since I missed this last one, I have to catch this one. Trust your senses. Not very helpful when you want to make sure that the 3-phase power supply is switched off.
Yeah, just licking your finger and giving it a touch isn't going to help.
Just pee on the power supply.
Russian ideas.
I want to.
What did you say, Gio?
You guys know what the Russian LED is?
The Russian LED.
Wait a second. Take a look at my screen. This is the Russian LED, right? This one.
Don't touch that.
Yeah, really don't touch that.
This is how you know that it's working.
Listen, I'm going to tell you something. That's not candy. Okay, so that
give it a lick.
Red,
it might
black luminosity. That's not candy that's making it look like that. Okay, don't touch.
So
I still remember seeing the guy get shocked in my when I was in my electronics technician school, and I just don't fuck with electricity, guys. That's all I can tell you.
So I wanted to tell everyone about Project Aristophanes. Me and a well-known scientific author, George Musser, are doing Project Aristophanes, where we're measuring angles from the sun at 4 points across the American northern continent at the same point on May the 25th. So if there's anyone in Montreal, New York City, California, or Lima that can either do the measuring or record/broadcast and help get it all set up, can you please email me at fighttheflatearth@gmail.com with the header Project Aristophanes, because we're going to prove that the Earth isn't flat.
Hey, Gio, did you see the request to put the Russian LED back up on the screen?
I'll just post it in my Discord channel. It's in the evil memes section. Oh fuck! Stupid Google link. Wait a second.
Mike says he's been shocked by 10 kilovolts. He said, boy, did I want to take a nap, but my mates talked me out of it. Could have ended up being a dirt nap there, Mike. Mike Boob.
Okay. I also posted the link in the side chat, so you guys can take a look at it.
It gives me a giggle every time I look at it.
Again, the red glowing color means that it's working.
Middlewell 531, it says, always keep one hand in the pocket of your trousers is what I've been told when doing electric experiments.
It's true.
Yeah, that's true. We weren't taught that. We were taught to just ground the whole thing out, unplug it, and then discharge every capacitor inside of it. So there was no electrical current to actually be working with.
Yeah, but you know that stuff can hold electric charge and yeah.
Oh, no, that's what I saw. That's where the guy got electrocuted. He was actually almost killed by an unplugged radar because the I believe it was a magnetron inside of it hadn't been discharged.
Let me guess, similar to an old CRT? CRT. Cathode ray tube.
Oh, yeah, absolutely. But they used to give us these silicon hand, like they almost look like swords with sheaths on them. They had hand protectors, and at the very end of it was a tiny piece of copper, and that's how you had to discharge it. If you got too close while discharging these capacitors, that arc would jump and hit you. And literally, they build these things. They mathematically build these things to protect you, so that if you take your hand and put it on the other side of the hand protector, guess what? You're now too fucking close.
Yeah, but team math isn't reality, so put your hand where you want. It's cool.
I actually got shocked once in the laboratory. I had plugged out a... Do you guys know what a rotationary stirrer is? A magnetic stirrer?
A magnetic stirrer?
Stirrer, yeah. Okay, basically, think about it as a heat plate. So you can actually heat your chemical vessels. Your flask.
Oh, right. Yes, I know what you mean.
Yeah, it also uses a magnet and a ball on the inside.
Yeah, it contains a rotating magnetic field that actually allows you to stir a stirring magnet that is submerged in the solution you're stirring.
Yeah.
So basically, it's just a fancy heating plate. Now, the old ones, when you actually plug them out, they still took a few seconds to actually, because there was the biggest magnetic coil in there. It actually took some time for that magnetic field to actually, discharge. Is that the right word for magnetic fields? Whatever. Anyway, for like 5 to 10 seconds, you could still measure a voltage on the two pins of the plug. And I accidentally once, after plugging this thing out, touched 2 of the pins simultaneously and got electrocuted.
Dope.
I mean, it was an old one. With new ones, this is not possible anymore. But yeah, obviously only maximum 230 volts, probably a lot less, but still painful as hell.
Yeah, if you're talking about the hand in the pocket so that you don't ground yourself out to complete a circuit, yeah, that would be a good idea. But when I was in the military, they never told us to do that. You had to use both hands for everything I did.
Really? In the Royal Navy, they'd say, "Come and touch that wire," just for a laugh.
No, I would never. After seeing what happened to the guy in my coming up in school, it made me definitely wary of dealing with electricity. It made me extra cautionary, which I never got shocked. So thank goodness I had the the Darwin Award contestant trying to teach me not to do dumb shit like that.
Apparently, Multi Tom Tom has challenged me to a debate. I think I could just record a soundboard and debate him, to be honest.
All right. No,
I could just like put some pre-programmed response to stupid Flurf 101. Like his last comment just now was, "Water proves the globe is a lie."
He's probably going on about this water being level thing, which they don't
Yeah.
understand.
Level
Well,
does not
military.
mean flat.
He says he worked at a radar site in the 70s. Were you military, Middlewell, or just civilian radar?
I mean, the guy's called Mittelwelle. That means he's probably a radio guy.
I don't.
Mittelwelle means is that UHF? No, it's HF, I think. It means radio with a middle wavelength. So Mittelwelle means middle wavelength. Military for 20 months.
Eric Chieftain says he's been shocked by 230 several times.
Yeah, it's not fun.
He is electric. No,
you have to remember we are running 230 volts over here instead of your 110.
We're hardcore.
Oh yeah, that's right. Yeah, I knew you guys were running.
We're also running at 50 hertz instead of your 60.
Yeah, we do 60 hertz.
I've just got like a couple of horses running in a treadmill thing.
Yeah. Hey, what up, Tao? Yeah, we're still on, bro.
Yeah, we're still on. 3 hours and 27 minutes at this point.
Oofed.
Which is why I think we're gonna end it very soon.
Yeah.
And also we're gonna stream.
Well, I would like to announce again. I know I've said it a few times in the past couple of days. This Saturday, me and Conspiracy Cats are going to be doing a charity FIFA event where me and one of my subscribers are going to be playing with him and one of his subscribers. And all the super chats, all the donations during that live stream will be going to the charity of the winner's choice. So I'm going to let you know now, guys. He stands no chance.
I want to announce something as well. On Saturday evening, I'll be on Jared Buto's channel, 82 Productions, when we are going to talk about Star Trek.
Awesome.
Just putting that one out.
I'll try to beat Conspiracy Cats real fast, so that way I can be there too.
Okay.
I mean, this might be something that just made people hate me now, but I'm kind of enjoying Star Trek Discovery.
Yeah. Okay, I have to throw you out now.
I mean, I tried to not like it, but
no.
I mean, I don't like the Klingons at all, but
yeah, nobody likes the Discovery Klingons.
No. I very much miss the goofiness of like Next Generation, and I mean, my favorite Star Trek series will always be Deep Space Nine.
It must, yeah, mine is it as well. Particularly everything after season 4, like there's this awesome period at the end of season 3, I think. Actually, I have to look that up, whether it's the end of season 3 or the end of season 4. There's like 5 to 6 episodes where every one of those is a classic. And that's pretty much the beginning where this Discovery, Deep Space Nine, is getting really good.
Yeah, when I was really gutted when it ended.
All the way back to what you leave behind, the end of season 7, the last season, the series final. That's awesome.
Ooh, Graham Houston says Voyager was pants. I don't know. Jerry Ryan was in it.
Yeah, but only after season 3.
Yeah, I kind of forget about season 1 to 3 of Voyager.
In the first episode of season 4, I think, Scorpion Part 2. But no. Let's actually do the Star Trek talk on Saturday. And
when's that?
Yeah.
8 p.m. or so my time.
Cool.
I think. Wait.
Oh, so y'all are doing midday here.
Yeah, sorry, but time zones are a thing. So, yep, 8 p.m. my time, which would be what?
It says like 2 p.m. Central.
2 p.m. Central. There's something wrong there. Anyway, we're gonna figure it out.
That sounds like fun. Bit of a change of pace.
Oh yeah. So let's do this the good old red rhetoric way and end the stream right here. You guys actually stay inside this time, so don't leave. Fight the flat earth. Say what you have to say, and then say your goodbyes.
I'm tired. Sorry. Bye.
you're not used to streams with now getting close to 4 hours of duration, right?
No, and the kids are off on holiday at the moment, so it's been like really busy and stuff here. I'm just
Our
a bit
stream
beat.
last night was 3 hours.
I'll say something better than that. I've got 2 videos coming out this week. Both are kind of halfway through being made. New episode of Flurfs Are Idiots with Schrodinger's cat about the Morgul, and an episode of Explaining Simple Stuff to Flurfs, funnily enough, called Spin of the Earth. So they'll be out by the end of the week.
Awesome. Okay, Team Skeptic, your turn.
Yeah, I'll do what Fight the Flat Earth was too scared to do and plug our new channel. Check out Science or Satire if you haven't already. I'm sure most of you have. I have to commend Fight the Flat Earth last night on a great performance against Nathan Thompson on my channel.
I had to bite my tongue so much.
I actually have not seen that one yet, and at least not completely.
The thing is when Nathan Thompson came in, he said, "Hey, I'd like to just talk to one person at a time." So I kind of stepped away and let Fight the Flat Earth kind of talk to him, since I'd already had my conversation with him a few days earlier. It was a completely civil conversation.
Which
didn't
was hard.
really. It was hard because I did my best not to cuss at him. I wanted him to stay around so that the people who were watching got a good show, and I think it came out to being a pretty good show. We're going to have him back on, but the episode has been uploaded to our Science or Satire channel. So if anybody would like to go watch it, they can. I'm going to upload a separate clip that is just the debate portion. When Nathan Thompson came in, I'll upload a second portion I'm going to upload. I haven't done it yet. I'm going to upload that. And, that way, if y'all don't want to watch the whole thing, you can always go and just watch the debate part. But it was a great show, and good job, Fight the Flat Earth.
Thanks. It was fun.
Okay, and with that, I'm gonna end it right here. For the actual still 116 people watching in the side chat on YouTube or whatever. Thank you very much for enduring Jeranism stupidity together with us. Thank you very much for joining, and I hope to see you next time.